Welcome to Prelim Preparation 2026. So this is going to be your preparation to this year's trial. Reason why I did this is that I went through the past papers for trial. They're a little bit trickier compared to the normal November paper. So I wanted you guys to be well equipped for your trial, as it contains a lot of marks in terms of like your final mark. So, and also the nice thing is that if you can master this and if you can do well in your trial exam, that means the fact that your November you have less stress. So that is why I decided to do this. So I have a recording schedule, right, or a release schedule on which when each paper is going to be released. So the preparation is going to start now, as you see in this video. So this is the release schedule, right? So it's within each date. So as you can see, the fact that we have June when each paper is going to be released, right? And also we have like July, right? As you can see, July is going to be like double releases because of like it's close to August, because then you have 1 month. And then we have lastly August, which is going to be this, completing the entire trial papers from last year. So this was very important for me to make sure the fact that by the time you guys write your trial exam, all the provinces are covered, right? Welcome to KZN paper 2. As you know that this video has a PDF version, and the PDF version is only available for people that are part of the membership. So to be part of the membership, I'll just show you on how to join and also how to get the PDF. So first I'm going to show you guys on how to join the membership. Obviously, you're going to search my name, then you're going to click on my profile, then you're going to land here, right? Then you have two buttons. You have the subscribe button, right? And you also have the membership button, right? So the join button is where you join the membership. So when you click on it, right, you'll see the fact that this is going to be the membership, right? Then it tells you what you get: membership only videos, early access, you get it, priorities, and all that, right? So now, do you see the fact that we already have exclusive content, right? So this content is strictly on the membership, right? So now when you say join membership, it's going to load, obviously. Then let me just say yes. Then it's going to load. Then when it loads, do you see the fact that now you're part of the membership, right? So when you scroll down, right, is that you're part of the membership, meaning you have access to all the members, right? So let me just go like this, right? So you can see the fact that you have you have everything that's related to members, meaning it's from the videos, right, to the most recent post, right? Then also now how to get the PDFs, right? So under members, you're going to see the videos. Then when you go through post, that's when you're going to see my post. You're going to see post of like public, and also when it's written to members only, you now can see it, right? As you see the fact that every time when I release a video, I do say the fact that there's a PDF. So this is the PDF for the NBT past paper, right? And also this is the PDF for the master series, right? Then this is like the normal posts, right? Then do you see the fact that this is the PDF for what? This is the PDF for paper 2, May, June. And also this is the PDF for what? For paper 1, right? Okay, so now let's go to one of the posts, right? We see the fact that this is the access. Now when you click on it, right, it's going to give you like Google Drive, because it's a Google Drive. So don't worry, it's public, right? So then when you scroll down, you'll see the fact that the PDF is within two versions, right? Is that you have the actual, it tells you that which PDF it is, right? Then you're going to have the question paper first, right? Then after having the question paper, then you're going to have the memo. The memo is exactly how the video is, but now it's in PDF format, right? So all of them are going to be like this, where you get what? You first get the question paper, right? Then underneath it is the memo. Hope that makes sense, right? So that is how you would get access to this PDF. So now we're going to do statistic, which is we're going to do question 1. It says the Road Traffic Inspectorate is doing research on legibility distance, the maximum distance at which the driver of the vehicle can read a road sign. For their research, they tested 12 drivers of different age to test their legibility distance Their hope is to improve the road safety by examining the relationship between the age, which is X, measured in years, and the legibility distance, which is Y, which is measured in meters. The table below lists the data obtained from the research, right? So we have this data. Then from there, we see the fact that this is going to be our X, which is the age, and legibility distance, which is going to be Y. So now for 1.1 and 1.2, what I'm going to do is that in the description, I'm going to put in a video showing you using the calculator on how to solve both these two, right? So I'm going to do that. So now I'm just going to give you the two answers for that. So the formula that you need to use for determining, for 1.1, determining the equation of the least squared regression line, right? For 1.1, we know that the equation of the least squared is y is equals to what? So it's going to be y is equals to a plus bx, right? So let me just put this inside a block in red. So now to find the equation is that using the calculator, you're going to find your a, which is your a is going to be 169,06. Then your b, which is going to be equals to negative 0,90, right? So therefore, the equation of the least squared regression is going to be y is equals to 169,60 minus 0,9x, and that is the equation, right? Then 1.2, so 1.2, also using the calculator, is that write down the correlation coefficient, right? This is basically solving for r. So we find the fact that using the calculator that your r is equals to 0,93. So using your calculator, you would have found both this value, right? Which I'm going to reference in the description so that you can use to basically know how to use the calculator to determine the two values. So now we're going to do 1.3. It says, referring to 1.2, comment on the relationship between the age and the legibility distance, right? So we see the fact that this is our r, right? So using to comment, this is what we're going to use, this table, and this is how we're going to write our answer. So first, we need to determine what r is. So how to write your answer, you need your strength, right? Which is going to be this options. Then you need to assign whether it's positive or negative, right? So first, by this, we need to determine where does it fall. We see the fact that it falls here, right? Negative 0.9 falls here, right? So it falls here in the negative. So let's do this. Let's highlight where it falls. So we see the fact that it falls here. So the sign is going to be negative and the comment or the strength is going to be very strong, right? So to write your answer, you're going to say what? You're going to say very strong. So it's going to be very strong, right? Negative, since it's negative, right? Very strong, negative coloration. So that's how you would comment on the relationship between what? Between the age and the distance. Hope that makes sense. So 1.4, it says predict the legibility distance for age 33. Give your answer to the nearest to the nearest meter. So what are we given? We given age, right? So we given age, and we know that age, right? We know the fact that age is what is our x value, right? So meaning what we're predicting, which is the legibility, the legibility distance, which is going to be this one, right? Is what? It's our y. So it's going to be our y. So now we know that our the least squared equation is y, right? Is equals to what? It's equals to 169. So let me just copy and paste it. So we know that this is our least squared equation, right? So let me just zoom it in. We know the fact that this is our equation, right? So we have x. So we know the fact that x is 33. So this is the same as y is equals to 109,60 minus 0,9, then 0. Then this is going to be what? 33, right? Because that's our age. Then punch that into the calculator. We're going to see the fact that y is going to be equals to what? Y is going to be equals to 139,90, right? So they said the fact that to the nearest meter, so we need to round, we need to round this up. So it's going to be y is equals to 140 meters. And the reason why is because of this is to the nearest meter. Hope that makes sense, Anna. So now we're going to do 1.5. It says calculate the estimated decrease. So let me just highlight the most important word. The estimated decrease legibility distance, right, per age, right, as the age increases to 15 years for over 18, right? For people over 18. Then they say we need to give our answer to the nearest meter. So to understand this question, we need to kind of understand the entire least regression formula and what a component means. Because of understanding what the equation means, it's going to make it very easy for us to know what they're asking us here, right? So I'm just going to go up and collect the least square equation, right? And we're going to understand each component in it. So let me just go down. So let's do this, right? So we already know the fact that this represents what? The legibility, right? Legibility distance, right? So we already know that. And that we know that x represents age. That we know, right? Then now let's discuss what this what this 196,6 means. In normal sense, we know the fact that this is the y-intercept, right? We know that this is the y-intercept because this is a linear function. And how do we get the y-intercept? Is that we need to let x equals to 0. Right? So in our theoretical, in this case, right, this is going to be the starting, the starting legibility distance. So the starting point, meaning what I mean is that when h is equals to 0, and this doesn't make sense, but hypothetically, right, is that when the age is equals to 0, when a baby is like 0 years, even we know the fact that a baby can't drive, but it says theoretically is that if we had a kid that is age 0, then the legibility distance would be this. See, hope that makes sense, right? So this is going to be what? This is technically the theoretical starting point, right? Theoretical. So this is the theoretical starting point, right? Starting point or legibility distance, right? When age 0. So this is for when age is equals to 0 years. We know the fact that doesn't make sense, right? Then this is the part that is important, right, to answer this question, right? So this one is the one that's important, this one, right? So this, we know the fact that in linear function, this is either our gradient, right, or the slope, which means the same thing, right? So in our case, translating it to what? To basically, to our situation, right? This negative 0.9 is the age penalty. So this will be known in this context. So in this context, right? In this context, this is the age penalty. This is the age penalty, right? So this is going to be the age penalty. What do I mean when I say age penalty, right? This is the age penalty, meaning for every 1 year, right? So for every 1 year, in our case, obviously, the age of like driving starts at 19 above 18, right? But is that every 1 year passing, right, is that the person would lose 0.9 vision. Hope that makes sense, right? So every 1 year, because of its decreasing, so for every 1 year, the person's what you call this vision, like how much they can see, decreases by what? Drops by 0.9 meter. Hope that makes sense, right? So I want to write it properly so that it makes sense. So I'm gonna say for every 1 year, so this means, so the negative 0.9, negative 0.9, right, means that for every 1 year a person is driving, for every 1 year a person is driving, right, they lose 0.9 meters, right? They lose 0.9 meters of like vision, basically, of vision. So that's what it means, right? So that's what it means. Hope that makes sense, right? So now, going back to the question, right, is that since we understand what each means, they say estimate the decrease in legibility distance, meaning using this, using this, right, we need to estimate, right, the decrease in legibility distance of age if it's like, if age increases to 15 years. So what are we calculating? We're going to take the decay. We know the fact that 1 year represents a decay of 0.9 meters, right, of losing vision. So now we need to calculate for 15 years, meaning to answer this is basically 15 multiplied by 0.9. So this over 18, right, for people over 18, we know the fact that people that can drive, and from our data set, is people that are over 18. So this is just to emphasize the fact that anyone below 18 can drive from our data. Hope that makes sense, right? So to answer this question, it's going to be the decay. We know the fact that a person loses their eligibility distance, right, at 0.9, like 1 year is that it decreases by 0.9. Now we need to calculate for 15 years, meaning it's going to be 15 multiplied by 0.9. Hope that makes sense, and that is going to be your answer. Hope that makes sense. So now let's answer it. So now it's going to be what I'm going to say, decrease. So it's going to be decrease, right, in legibility distance. It's equals to what? In 15 years, right? It's equals to 0.9, 0 multiplied by 15 years. And this is going to give you 13,5 meters, right? But they say the fact that you need to round it up to the nearest what? Nearest meter. So this is technically equals to 14 meters. So within 15 years, right? Within 15 years of driving, this person is estimated to lose 14 meters, right? It's estimated to lose 14 meters of like their eligibility distance. Hope that makes sense, right? Now we're going to do question 2. It says, so let me just zoom it in. A farmer germinated 200 seeds of a rare and valuable tree species and planted the seeding in the pot, right? In pots. The pots were placed in a greenhouse where they would grow faster than the outside. After 1 year, the height of the seed, after 1 year, the height of the trees in the pots were measured and an ogive was drawn, right? So they tell us the fact that the shortest tree, right, is equal. So let me just unzoom. Okay, go back to highlighter, make it small. They tell us that the shortest tree is equals to 41 centimeters, and they tell us and the tallest tree is 88 centimeters, and this is the ogive, right? Now with that let's answer the first question, right? It says draw a box and whisk diagram of the height of the trees after 1 year. So now here's the number line, right? So to draw a box width diagram, we need what you call this 5 numbers, right? So we need the minimum. So in our case, since we're doing related to trees, so we need the minimum tree, we need the maximum, right? Then we need Q1, then we need Q2, and we need Q3, right? So the minimum, if you go back, is that I've already highlighted. We know the fact that the shortest tree is 41 centimeters, meaning the minimum is 41 centimeters. Then they tell us the fact that the tallest tree is 88, meaning the maximum is going to be 88 centimeters, right? So now calculating Q1, Q2, and Q3, right? So now to calculate Q1, Q2, Q3 is that we always use the cumulated frequency side, right? So to find the what you call this Q1, Q2, we need the total side of the cumulative. So meaning in our case, we know that the cumulatives, what you call this, the cumulated frequency side is measuring is the seeds, right? And this part, which is we want the height, is going to be the height of the trees. So the total seeds, we are given what? We were given the fact that the total seeds were 200. So we need the total seeds. So we know the fact that in our case, it's going to be 200, right? So we know the fact that we have 200 seeds. So the reason why we need the total seeds is that we know the fact that to calculate Q1, it's going to be the total, which is going to be 200, always multiplied by 50%, which is 0.5. Then now for Q2, right, it's going to be always the total multiplied by 0.25, right? And lastly, Q3 is going to be 200 multiplied by what? By 0.5, right? So now the 50% of 200, we know the fact that that's going to give us 100, right? Then we know the fact that 0.5, or what you call this, 25% of 200 is basically 50, right? Then we know the fact that 200 multiplied by 75% is basically 150, right? So now going back to the diagram is that these numbers, right? Do you see these numbers? Is that we're gonna look for them here, right? So we're gonna look for them here. So we know the fact that this is gonna be, and we're gonna do it in red, right? We're gonna look for 100 and we're gonna just zoom it in. Let me just zoom it in, right? Draw a line going straight like this, right? And go down to figure out what is the height of the what? The height of the tree at Q2. So this part is going to give me Q2. So this is going to be where Q. Ooh. So let me just maybe decrease my. Okay, cool. So let me just decrease it. So this is going to be your Q2. Hope that makes sense, right? So let me just increase it. Then we're looking for Q what? We're going to look for Q1. Q1 is at 50, right? So we know 50 is going to be here. So you're going to take your ruler. So come at 50 and like this. And when it touches, you're going to go down like this, right? Then you're going to calculate what is going to be this. So we need to find how many blocks are there from here to here, right? So we see the fact that this is 50. So this is 1, 2, 3, 4, 5. So we know the fact that that makes sense, meaning it's going to be 56, 57, 58, 59, then 60. So this is 56, 57, 58. So this is going to be what? This is going to be 58, right? So let me just decrease my pen. So this, we know the fact that this is 50. Sorry, let me just go back. Let's calculate again. Sorry, this is going to be 56, 57, 58. So we know the fact that this is 50. This is 58. And our 58 is what? This is Q1. So 58 is Q1. Hope that makes sense, Anna. And now we know the fact that Q3 is 150. So we're going to go back and we're just going to increase our pen. And we're going to go to 150. Draw your pen. Go straight to the diagram, to the ogive. Then, okay, cool. With your ruler like this, right? Then we're going to go down. So this is 76. So we know the fact that it's going to land at 76. So we know the fact that it's landing at 76. and this is Q3, right? So now, knowing our total, we know the fact that our Q1, Q2, and Q3, we know that Q1 is 58, we know Q2 is 50, it's 70, and Q3 is 76, right? So now with that, let me just do this, increase, right? So now we're going to draw a box whisker, right? So we know the fact that this 41, so 41 is somewhere here. Let me just do this. We know that 41 is somewhere here. That's going to be what? Our minimum. Then 88 is going to be somewhere here. That's our maximum, right? So let me just put this, right? So we know the fact that that's 41 is there and 88 is going to be our maximum there, right? Then our box is going to be somewhere here. So we know the fact that our box, so I'm going to draw lines. We know the fact that, let me just draw dots, right? We know the fact that Q1 is 58, right? So it's going to be somewhere here. So it's going to be somewhere here. That's where 58 is going to be. Then Q2 is going to be 70, so it's going to be here. Then lastly, 76 is going to be here, like that, right? Then we know the fact that our box is going to be where? It's going to be this. This is going to be our box, right? So this is going to be our box, right? It looks ugly, but then we connect it here like this, which is going to be our maximum and minimum. And this is going to be our box whisk, because we know the fact that this is going to be our minimum, and this is going to be our maximum, and this is Q1, Q2, and lastly this is going to be Q3. And this is how you would draw your box whisk diagram. Hope that makes sense. So now we're going to do 2.2, right? It says describe the skewness of the data. So looking at the box whisk diagram, that's where we can comment on the skewness, right? We see the fact that there is more data. If you're looking at the box, right, we see the fact that there is more data in the left side, right? You see the fact that looking at the Q2, right, there's more data this side compared to this side. Meaning, since there's more data here, that's why we're going to say the fact that it's skewed to the left. Hope that makes sense, right? As since there's more data this side, that is why we're going to say the fact that this is skewed to the left or negatively skewed. So our answer is going to be the data. So it's going to be the data. So the data is skewed, right? It's skewed to the left. Skewed to the left, because that's where more data is. Hope that makes sense, Anna. So now we're going to do 2.3. It says the trees can be sold as soon as they reach 75, right? The height of 75 centimeters. Will the farmer be able to sell more trees in the short term if the data is skewed to the left or is skewed to the right? Okay, so now what we're looking at, we're going to look at the box whisk, right? So we see the fact that from from 70, which is Q2, till 76, that is okay, from here till here, right? Where this is the maximum, it's more or less like the tallest. But from here to here, this is the bulk of trees that the farmer can sell, right? We see the fact that that portion, even though it meets the criteria, right? The criteria of 75, right? Is that there isn't enough trees that are here because of majority of the trees are here, right? So the farmer can sell more trees still at at skewed to the left, right? Even though we know the fact that it starts from here, but still this is also closer to 75, right? Do you see the fact that from here till here, this 70 is still close to 75? So the farmer being skewed to the left, right, still can sell more, even though this ones, right, are closer to the selling, but there isn't enough trees because of majority of the data is this side. So to answer this question, it's going to be still the farmer is able to sell more trees when it's still skewed to the left, right? So it's going to be skewed to the left. So now we're going to do 2.4. It says the farmer selected 14 of the trees to to undergo special experimental treatment to make them grow faster. The height of those trees in centimeters are as follows. So this is the height. Then they say the fact that calculate the standard deviation of the height of those trees. So this is just using your, what you call this, using your calculator, right? I'm going to reference the master statistic where it shows you on how to calculate standard deviation, right? So we know the fact that after using your calculator, this is going to be your answer. So your standard deviation, right, is going to be equals to what? It's going to be equals to 12,63, right? Using your calculator. Then 2.4.2, it says how many of the trees have a height outside one standard deviation from the mean, right? So this is one standard deviation, two standard deviation. This is the formula that you're going to use, right? So the formula is basically going to be x bar, right? Then it's going to be minus n standard deviation, right? Then it's going to be x bar plus n, then it's going to be standard deviation, right? So where n, right, can be equals to 1 or 2 or continuous standard deviation, right? So it's going to be standard deviation. So this is the formula. So we're going to put it inside the box. Red. So in our case, right, is that we're looking for one standard deviation, right? So meaning n is going to be equals to 1. So we see the fact that n, let me just erase this. We see the fact that in our case that n is going to be equals to 1 because they said one standard deviation. We know that the standard deviation from the previous is equals to 12,63. Then mean, right, mean bar, right, is going to be what? It's going to be the summation of everything, right? So it's going to be the summation of everything. So let's find the mean. So we know the fact that it's going to be 46 plus 47, right, plus 51 plus 53 plus another 53, then it's going to be plus 56, then it's going to be plus 62, then it's going to be plus 68, plus 70, then it's going to be plus 71, then plus 74, then it's going to be plus 77, then it's going to be plus 81 and plus 86, and that is going to be divided by the total number, right? So they told us the fact that they took 14, they selected 14 trees. We can also count them as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So just to confirm here, we have 14. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is going to be divided by the total, right? Which is going to be 14. Sorry. Erase this. So it's going to be divided by 14, right? So x bar is going to be equals to, add up the numerator. So the numerator is going to be 895, right? Divided by what? Divided by 14. Punch that into the calculator. Therefore, x bar is equals to what? Is equals to 63. So it's equals to 63, comma what? Comma 93 centimeter. Right, so now we have your x bar, you have your n, and you have your standard deviation. Now let's use the formula. So the formula is x bar, so it's going to be 63,93, right? Minus, right? So it's going to be minus 1 standard deviation. So it's going to be minus 1 multiplied by the standard deviation, which is 12,63, right? Is to another x bar, which is 63,93, right? And this is going to be plus 1 multiplied by 12,63, right? So this is basically going to give us what? This is going to give us 50. So it's going to be, this when you add it up, it's going to be 51, right? Comma 29. And this is going to be 76, comma 5 7, right? So now this is the standard deviation, right, for what you call this, the mean of one standard deviation, right? So what I'm going to do is that I'm going to highlight trees, the trees height that fall within this range, meaning I'm going to start from, it can't be 51, right? So I'm going to start from 52, then I'm going to end at 56. Anything that is outside those two is not what I want. So that's what I'm going to be highlighting, right? So I know the fact that this one, right, this one 51, no. So this, right? Then till 54, it's everything that's in between, right? So that's everything that's in between. So from here till here, right, that's in between, right? That's inside, basically. Let's say inside. But remember the question, they said the fact that they want outside, right? So meaning everything that I didn't highlight, meaning from here to here, is going to fall under outside, the first standard deviation, and from here to here is going to be outside, the first standard deviation. So how many trees fall outside, right? We see the fact that this is 3 and this is another 3. So it's a total of 6 trees. So it's 6 trees. So it's 6 trees that fall outside the first standard deviation. Standard deviation. So that's how you would answer this question. So now we're going to do analytical geometry. We're going to do question 3. So it says in the diagram AD and F are vertices on triangle ADF. So we see the fact that this is ADF, right? So they are points on the triangle, right? And they further tell us the fact that AD has an equation of y is equals to half plus 6. So we see the fact that AD, so this line has an equation. So let's fill in the equation, which is the equation for this line. I'm just going to put it here. It's y is equals to 1 over 2 x plus 6, right? They tell us the fact that AD cuts the vertical x-axis at C. So we see the fact that this point C here, using this equation, right? So this equation, this line has a x-intercept. So C is the x-intercept, right? Then they tell us that B, which is here, is a point that lies on the line AD, right? And they tell us the fact that E lies on where? E lies on DF, such that, then they tell us the fact that such that BE is parallel to the y-axis. So what do we know about a line, right, that's parallel to the y-axis is that this point here, right, the x-coordinate with this two, they share the same x-coordinate. So here, the coordinate is going to be -4, right, and YE. And the reason we can find that, because of they told us the fact that this line here, right, is parallel to the y-axis, meaning this point here at 4, which you can see the fact that this is going to be -4, it's going to be the same point here at E. Hope that makes sense, right? Then is parallel to the y-axis, and they tell us the fact that AF cuts the x-axis. So they tell us that AF, so is AF, so we see the fact that AF, so AF cuts the x-axis here at G. So that's going to be the x-intercept for this line AF. Then they tell us that BG is drawn, right? And they tell us that the equation of DF, so DF is where? So the equation of DF, so this line, the equation for that is going to be 5y. So let me just do this. It's going to be 5y, right, plus 2x plus 60 is equals to 0. So what I'm going to do here on the side is going to be, I'm going to basically write this equation in terms of y is equals to. So let's do that, right? So we see the fact that we have 5y plus 2x plus 60 is equals to 0. Let's write it in terms of y. So we're going to take everything to the other side and leave 5y on the other side because we want to make y the subject. So it's going to be 5y is equals to negative 2x. That's going to be minus 60. So it's going to be y is equals to negative 2x minus 60 is divided by 5, right? So therefore, y is going to be equals to what? Is equals to negative 2 over 5x. Then it's going to be minus 60 divided by 5. So when you say 60 divided by 5, you're going to get, so it's going to be y, it's going to be minus 2 over 5 x, then 60 divided by 5, you're going to get negative 12. So now let's update this equation. This equation is the same as y is equals to what? It's equals to negative 2 over 5x, and this is going to be minus 12, right? So with that said, that gives us the entire information. We can start answering the first question. So now answering the first question, it says calculate the gradient of BG. So BG is going to be this one, so this gradient of this line. So we need to calculate the gradient of this line, right? So we know the fact that the gradient formula, let me just take the point. So it's going to be negative 4 is to 4. And G is going to be 6 is to 0, right? So the gradient of BG is, I'm going to say the gradient of BG is equals to YB minus YG, right? Divided by what? Divided by XB minus XG. Always keep the consistency. If you're going to start with B, make sure the fact that your X is B. If you started in G, make sure the fact that the denominator is also G. Keep the consistency, you know? So therefore, the gradient is going to be equals to what? It's going to be YB is going to be 4 minus 0, right? Divided by what? Divided by negative 4 minus 6, right? So when you punch that into your calculator, you're going to get your gradient is going to be negative 2 divided by 5. So that's going to be your the gradient for BG. So now we're going to do 3.2, right? It says show that show that BG is parallel to DF. So now we know the following, right? If BG is parallel to DF, right? Then we need to prove. Then we need to prove that the gradient, right? So if two lines are parallel, that means that the gradients are equal, right? So we need to prove that the gradient of BG, right, is equals to the gradient of DF. But remember that they said show, right? So we know the fact that the gradient of BG, why do I keep on saying BF, right? Of DG, right, is equals to negative 2 over 5, and this is proven in 3.1. Hope that makes sense, right? So now we need to prove that DF is basically equals to what you call the gradient of DF is equals to negative 2 over 3. And if you go up, remember the fact that when we did this, I already proved it, right? So that's what I'm going to write. So this, right? So we know the fact that we're going to take this and prove that the gradient is equals to negative 2 over 5. We can't just write it. We need to show it, right? Right? So we know the fact that from, so I'm going to say from the line equation of DF, right? And we have the line equation as being what? As 5x. So it's going to be 5y, right? Plus 2x, right? Plus 60. So it's going to be plus 60 is equals to 0, right? So now I'm going to write it in terms of y. So since we already write it in terms of y, let's just take it, right? So it's going to be y is equals to negative 2 over 5x, right? Is equals to, it's minus 12, so it's minus 12. So therefore we see here that the gradient of DF is equals to negative 2 over 5, right? So we see, so therefore we also see that the gradient of BG is equals to the gradient of df, which is equals to negative 2 over 5, right? So that means BG is actually parallel to DF. And that's how you would show that BG is parallel to DF. Hope that makes sense, Anna. So now we're going to do 3.3. It says calculate the coordinate of D. So let's go up and see where is the coordinate of D. We see the fact that D is here. But what do we see? We have already this equation and we have already this equation. D is an intersection if we extend these two lines, right? It's an intersection between this equation and this equation, right? So we're going to say D is an intersection. So D is the intersection, right, between line, go up, line AD, right, line AD, and line, go up again, line, line AD and line DF, and DF. And we have both the equation, right? So we know that Y AD is equals to a half. So it's equals to a half x, go up, plus 6, and the equation for line DF, it's here. It's going to be negative 2 over 5 minus 12. So we're looking for what? To look for F, to look for D, it's basically line AD is equals to line DF. Hope that makes sense, right? So now let's substitute line AD, right? So we see that line AD is basically a half x plus 6 is equals to, so that's going to be equals to negative 2 over 5 minus 12, right? So negative 2, and what you call is negative 2 over 5x minus 12, right? So we're going to take everything with x to one side and everything with the number to the other side, right? So that's what we're going to do. So we're going to have a half x, right, plus 2 over 5 x is equals to what? Is equals to negative 12 minus 6. So when you add this side together, you're going to get 9 over 10. So it's going to be 9 over 10 x is equals to, when you add the other side, you're going to get negative 18, right? So now we're going to get rid of the 10, right, in the denominator. So it's going to be 9x is equals to negative negative 18 multiplied by 10. Hope that makes sense, right? So when you say negative 18 multiplied by 10, right, you're going to get the following. You're going to get 180. So 9x is equals to negative 180, right? So now we're going to solve for x, divide both sides by negative 9. So it's going to be x is equals to negative 180 divided by what? Divided by 9. Therefore, x is going to be equals to negative 20, right? But we're looking for the coordinate, right? So meaning we're going to substitute x equals to negative 20 on either or. You can substitute it here, you can substitute it here. It really doesn't matter. So I'm going to substitute it here, right? So when I substitute it into YAD, so we see that y is going to be equals to a half x, right? Remember plus 6, so it's going to be plus 6. So when you say y is equals to 1 over 2, then you're going to have negative 20 plus 6. Punch that into the calculator. You're going to get that your y is going to be equals to negative 4. So therefore, your coordinate of D is equals to negative 20 is to negative 4. And that's how you get the coordinate of. So now we're going to do 3.4. They say calculate the length of BE. So let's go up. BE is this one, right? We need to calculate the length of BE, which is this one. We have a full coordinate of B, but we need the full coordinate of E so that we can calculate the entire length. Hope that makes sense, right? So we know the following. We know the fact that since this is parallel to the y-axis, it shares the same x coordinate. And since we have the equation of this line, we can substitute this to calculate ye here. Hope that makes sense. So let's do that first. So we know that the coordinate of B, right? So we know that the coordinate of B is -4. S2, let's go up. So it's -4, S2, +4, right? So it's -4, S2, +4. And we need to calculate, so, and we know that E is -4, S2, YE. So calculating YE, right? So we're going to substitute x is equals to -4 into what? Into df, into y df, right? So we're going to substitute it into y df. So let's go back. Yes, it's to y df, and we already know that the y df is equals to -2/5x. Let's go back. -12. So it's going to be -12, right? So it's going to be -12. So now we know the fact that ye is equals to what? To -2 divided by 5. Then it's going to be -4, and it's going to be -12, right? So when you substitute that, you're going to get that your ye is equals to what? Is equals to -10,4. Right? So you're going to have that, meaning the full coordinate of E is basically -4 is to -10/10.4. Hope that makes sense, right? So now calculating the length. So we know that the length that we're looking for is BE, which is going to be equals to the square root of xb minus xe all squared, plus then it's going to be yb minus ye all squared, right? So just put in the square root properly, right? So now let's substitute, right? So when substituting, we know the fact that this is going to be equals to, let me just do this. So it's going to be, oh yes, it's going to be square root, then it's going to be -4 minus -4 all squared, plus then it's going to be y, it's going to be 4 minus 10/4 all squared, right? So that inside the square root. Then let's clean this up. So this one is going to give me 0 all squared, right? And this side is going to give me what? It's going to give me what you call this minus, so it's going to be 14.4 all squared, right? So you're going to have it as equals to square root of 14.4 all squared. Then the square and the square root are going to cancel out. They're going to cancel each other. So it's going to be 14.4 units. So now we're going to do 3.5. It says, let J be a point in the third quadrant. So J needs to be somewhere here, right? Such that DJEB, so DJEB, right, in that order forms a what? Forms a parallelogram. So what do we know about parallelograms? We know that opposite sides are equal, right? And also parallel, and also what you call this, opposite sides are equal, and what you call this are parallel to each other. So we know the fact that in that order is going to be DJ. So J needs to be somewhere here because it's in the third quadrant, right? So it's DJ, then it's going to be E, then it's going to be B, then it's going to be like this. So this is the parallelogram. So let me just draw it, right? So we know the fact that this needs to be D. Okay, go. Let me just erase this. So we know the fact that's going to be dj, so it's going to be here, right? Then it's going to be like this, then this connects to this, and this connects together like this. So this is the parallelogram that we're dealing with, and point J is going to be here, right? So what do we know? We already know the coordinate of the coordinate of D. So here we know that the coordinate is -20, right, is to -4. And since this line, right, is parallel to this line, so we know the fact that these two are parallel, right? And also it's parallel to this line, meaning this coordinate here is going to be -20 is to J. So it's going to be what? It's going to be YJ, right? Because we don't know the J. And we also know what E is, right? So we also know what E is. So let's go up. And we know that E is -4. So E is -4 is to what? Is to 10, -10 over. So -10 over 10.4. Right? Like it's saying over, right? So this is the whole parallelogram, right? We need to calculate the area of it. So now calculating the area of a parallelogram, and I'm going to just write the notes here, right? So the area of a parallelogram is equals to, so area, right, of a parallelogram. So parallelogram, so parallelogram is equals to where? It's equals to, let me just move this because it's too much on the side. It's equals to the breadth times the height. And now from the diagram, we need to understand what that is, right? So we need to understand what that is. So I'm going to just draw a parallelogram, right? So drawing a parallelogram, we know the fact that it's going to be two lines that are basically equals to each other, but it creates a parallelogram just like this. So these two are going to connect. So it's going to be like this, where we know the fact that this two, not only are they parallel to each other, but they're equals to each other. And also these two are parallel to each other and also equals to each other, right? So we know that, right? So the base is going to be what? It's going to be this lines. Do you see? This is going to be the base. So this, let's highlight it. This is going to be our base, right? So this one is going to be the base. Then the height. How do we find the height, right? The height, do you see the fact that where it touches straight, right? Do you see the fact that where if I create a line going from the vertex going down and it cuts 90 degrees, that is going to be how you form your height. So forming your height is going to be like this. It's going to be from a vertex going down and it creates a 90 degrees. That's going to be the height, right? So you see the fact that I cannot form a height from like the opposite side. So what I mean the opposite side is that if I take a point here and go like this, do you see the fact that this is not going to form a 90 degrees? So where it's not slanted, do you see this? Where the lines are not like slighted, like on a tilt, right? We can't form a 90 degrees. We want where our base, right? Our base is the line that can create a 90 degrees. I hope I'm making sense, right? So this one cannot create the height and cannot be the base. Only the base is the line that basically is on the plane. So it's directly down. Hope I'm making sense. Such that if I take a point up and go down, it creates a 90 degrees. So that's how you would basically find the area, right? So using that. So with that said, let me just put this inside a block in red, right? So that's the information that we have. Now looking at our diagram, right, is that, do you see the fact that the height, right, the height needs to be the one that is straight, right? We see the fact that from this case is that this, from here, we can only have a height. This can be our only height, right? Because if I draw a line from this point going down, do you see the fact that this is going to create a 90 degrees, right? This can be our height. Hope I'm making sense. So our height is from this point going down like this, right? That creates our height, meaning also this is our base. So as I established this, since it's going to be a point from going here to here, or it could be here going to there, it really doesn't matter. I'm going to use the one that going here to here because of I already know what the base is. Our base is BE, right? So now let me write everything. So we know the fact that our base is going to be equals to this. So it's going to be this line, right? So this is going to be BG. So it's going to be our base, right? So go back. So this is going to be our base, right? Then our height is going to be, I'm going to draw it in dotted lines, right? So our height is going to be no in dotted lines. So I'm going to draw our height here. So it's going to be from here going down like this. So that is going to be our height. So our base is going to be that one. This is going to be the base. And this is going to be the height. Right? So we see that the height is what? Is an intersection between those 2 points, right? So it's the height, to find the coordinate of the height, which is going to be here, right? It's the height shares the same the x coordinate as what? As this one, as B. So we see the fact that the height shares the same coordinate as B. So we know the fact that here the coordinate is going to be -4 is true. Then it shares the same coordinate, the same y coordinate as what? As our D, right? So it's going to be 4 is to -4. That is going to be that point. So we need to calculate the length between these two, right? We need to calculate the length of this from here to here, right? So to calculate the height, so we already know that the base, right? So we know the fact that area of DJEB is equals to the base multiplied by the height. So we know that the base is equals to 14, so we know that the base is equals to BE. So we know that the base is equals to BE, which is equals to 14, go up 14,4, right? And now we need the height. So the height is equals to what? Is equals to square root. Then it's going to be, let's call it h here. We'll call it h, right? To that point, we'll call it h. So we know the fact that it's basically going to be XD. So let me just do this. So we know that the height, so before that, we're going to say let h equals to -4 is to -4. So that there's consistency. Then after that, we also know the fact that point D, right? Point D is equals to -20 is to -4. Hope that makes sense, right? So now we're looking for height. So we know that the height is equals to what? Is equals to DH, right? Which is going to be equals to this, which is going to be XD minus XH all squared, plus then it's going to be YD minus YH, and it's going to be all squared, right? So we're going to put this. Then now we know the fact that this is going to be H is basically going to be equals to the square root of XID, which is going to be -20 minus 4 all squared, plus YD, which is going to be -4. Why is that saying comma? Minus 4 all squared, right? Then we see that H is equals to, then here we're going to have what? We're going to have -20 plus 4 all squared, plus then this is going to give me 0 all squared, right? So therefore h is going to give me what? It's going to give me the square root of negative 16 all squared, right? So this is going to be all squared, right? So now h is equals to, this is the same as having the square root of, this is going to be negative all squared, then this is going to be 16 all squared. So I'm distributing the square, right? So this is going to give me that. So h, anything that's negative, if it's squared, is going to become positive. So this is going to be positive. So this is the same as positive 16 all squared. So the square root and the power 2 is going to cancel out. So your height is going to be equals to 16, right? So your height is going to be equals to 16 units. So now we know that the area of DJEB, so let me copy and paste this, right? So we know the fact that the area, right, of DJEB is equals to what? Is equals to, the base is 14,4 multiplied by the height, which is equals to 16, right? So now when you multiply the two, we see that the area is going to be equals to 230,4 unit square. So now we're going to do question 4. It says in the diagram, the equation of the circle with the center M is, and they gave us this equation, right? So from this is that we can determine what? We can determine the center M, so the coordinate of center M. And how do we do this? Is that this, right? So this is the XM, right? And this is YM, right? But from the coordinate, do you see the fact that from the equation, here it's positive and also here it's negative? We always take the opposite sign. So since we have them inside a bracket, since here inside the bracket is what? It's positive, meaning outside it's going to be negative. And here, since inside the bracket is negative, so meaning it's going to be positive. So it's going to be positive 4. So now updating here, it's going to be what? It's going to be negative 3 is to positive 4. So that's the coordinate of M. Hope that makes sense, right? Then they tell us the fact that PMR, so PMR, this line is the diameter to the circle. And they tell us that the equation to the tangent, right, which is QRST, right, to this, what you call this, to the circle at point R is this. So we have that the equation of this line is y is equals to 1 over negative. So let me just do this. It's negative 1 over 5 x plus k, right? So we do not have the k. We do not have k, which k is the y-intercept, which is this point, is, right? So meaning this point is basically what? It's basically 0 is to k. So when we find k here, we can find this one. Hope that makes sense, right? So they tell us the fact that Q and S are respectively the x and y intercept or for the line SRST. So meaning this point Q is the x intercept and this one is the y intercept. Hope I'm making sense. Then it moves, then they tell us the fact that PWVT, right, is the straight line. So PWVT is a straight line, right, such that the y-intercept is at W and the x-intercept is at V, right? So with that information, now we can go and answer the questions. So now we're going to do 4.1.1. It says, calculate the coordinate of M, right? So we already know that the coordinate of, write down the coordinate. So we're not even calculating, we're writing down the coordinate of M. So we see the fact that M from what we have taken is negative 3 is to 4. So let's just do that. So let me go back to my black. So we know that M is what? It's negative 3 is to 4. So it's going to be negative 3 is to 4. So now we're going to do B. It says write down the length of the radius. So the length of the radius comes from the original, right? So from the equation of the circle, which is this one, right? So we know the following. So the standard form of the equation of a circle with the center is basically x minus a, so it's x plus a squared, plus then it's going to be y plus b squared is equals to r squared, right? Where a and b, so negative a and negative b is the center, and the radius, so it's the center, and the radius, right, is equals to what? The square root of r squared. So that is the radius, right? So from what we have, we know the fact that the equation of the circle is what? So let's take the equation of the circle. We know that the equation of the circle is x plus 3, so it's going to be x plus 3 all squared plus y minus 4 all squared is equals to what? Is equals to 26. So we know the fact that there's 26, so we know that 26, right, is basically r squared. So to find the radius, we know that the radius, the length of the radius is basically square root of r squared, which is the same as the square root of 26. So r is going to be equals to root 26. Hope that makes sense. So now we're going to do 4.1.2. It says determine the equation of the diameter PMR. So let's go up. We see the fact that we need the equation of PMR, right? So we need that equation. But we see the fact that to find the gradient, right? So we know the fact that to find the equation, we're going to use this formula, which is going to be y, right? It's going to be, I'm going to use this one. It's going to be y minus y1, right? Is equals to m. Then it's going to be x minus x1. So what do we need here? We need the gradient. So we need the gradient. So I'm going to highlight what we need. We need the gradient, and we also need a set of coordinate. But to calculate the gradient, right, if we're going to use this line, right, is that we need 2 points. So we see the fact that we only have the point R, right? But we do not have a point here. We do not have the point here. So we do not have both those points here, right? So what is our best thing? We know the fact that since this is a tangent and this is what? This is a radius. From Euclidean, we know the fact that this creates a 90 degrees, and the reason for that is radius perpendicular to tangent, right? So we know the fact that now we know the relationship between the gradient of the gradient of two perpendicular lines is that when you multiply them together, you get what? You get negative. So now what we're going to do is that we're going to take the gradient from here, because we already have the gradient of this line, right? Then we're going to find the gradient of this line. Then we're going to use this set of coordinate, right, to basically find C, or to complete our equation. Hope I'm making sense, right? So now let's update this formula using that. We know the fact that the point that we're going to use. So first, we know the fact that we need the gradient, right? So to find the gradient, so I'm going to do this. I'm going to update it, replacing. So replacing, let me do this. Replacing y1, comma, and replacing x1 and y1 and the gradient, right? With what we have, what we have to solve for the equation of the diameter PMR, right? So now we know the following. We know the fact that y1 is to x1 is to y1. It's basically equals to the coordinate m, which is going to be what? Which is, we calculated it as being -3 is to 4, right? So, and also our gradient, I'm just going to write the gradient of PMR. So PMR, right? So now what do we know? We know that the gradient, so we know that the gradient So we know that the gradient of PMR multiplied by the gradient of the tangent, which is QRST is equals to -1. And the reason for that is going to be what? Is because tangent is perpendicular to radius. Right? That's from Euclidean. So if that's the case, we already know that the gradient of QRST is equals to, let's go up. We already know that's equals to -1/5. So we already know that is equals to -1/5. So therefore, we know that the gradient of PMR, right, multiplied by -1/5 is equals to -1. Since it's multiplying, the other side is going to be dividing, right? So meaning the gradient of PMR, right, is basically equals to -1 divided by -1/5. So the gradient of PMR is basically equals to +5. Hope that makes sense, right? So now what do we have? We have the fact that update the equation. So we know the fact that it's y minus ym, right? It's equals to the gradient of PMR, right? It's going to be x minus xm. So now let's substitute, right? So we know the fact that y minus, what's ym? So we know that ym is 4, so it's going to be -4. It's equals to the gradient. The gradient is 5. Open bracket is going to be x, then x minus 3. So it's going to be x minus 3, right? So now let's clean this up. So it's going to be y minus 4 is equals to 5. Then this is going to be x plus 3. Then it's going to be y minus 4 is equals to 5x, right? Then 5 multiplied by 3 is going to give me 15, right? So now it's going to be y, make y the subject. So it's going to be 5x plus 15, and it's going to be plus 4. So therefore, our equation for the diameter is going to be 5x, and this is going to be plus 19. So that is the equation of the diameter PMR. So now we're going to do 4.1.3, which is determine the coordinate of R. So we're going to go back and see where R is. We see the fact that R lies here, right? So R is two things. It's an intersection of the tangent line, right, which we already have the equation, and this line, what you call this, the diameter line, which is we already have the equation, and also the tangent line, right? So the thing is, we could use this one that we found and this one and basically intersect them because of they both meet at R. But the problem is that the equation of the tangent is not complete. We do not know what K is, right? But again, is that since this is a tangent, right, and R is also the point of contact of the curve, so this is an intersection between what? The circle equation and also this tangent line, right? Or the circle equation and also what? And also this, this diameter line. So since we have the complete equation of the diameter and also we have the complete equation of the circle, we're going to use that to find R, right? Hope I'm making sense. So let's do that, right? So we know the following. R is an intersection. So we're going to say R is an intersection. R is an intersection between the circle, right? Between the circle and the diameter. Diameter. So we already know that the equation of the circle. So we have that the equation of the circle. Equation the circle. Right, we have the equation of the circle, which, let's go up, is this one. Right, and we have the equation of the diameter, which we found is this one. So we see the fact that we cannot necessarily intersect them, right? But what we can do is that we can substitute the equation of the diameter into the equation of the circle. So wherever I see y, I'm going to substitute by this, right? So that's what we're going to do. So we're going to substitute the equation, why am I spelling equation wrong? The equation of the diameter into the equation of the circle, equation of the circle. So let's do that, right? So meaning we're going to have x plus 3 all squared plus y. So now wherever we see y, we're going to substitute by 5. So let's put in square bracket here. So it's going to be 5x plus 19, right? It's going to be minus 4. It's going to be all squared is equals to 26. So this is going to be square bracket. Hope that made sense, right? So now we're going to clean this up. So when we clean this up, we're going to have x plus 3, then all squared plus, then this side is going to be 5x plus 19 minus 4 all squared is equals to 26, which is going to be x plus 3 all squared plus, then this is going to give me 5x, and this is going to be plus 15 all squared is equals to 26. So when you expand this one, you're going to get it as being x squared, right, plus 6x plus 9, then plus, then when you expand this one, you're going to get it as 25x squared plus 150x, then this is going to be plus 222, right? And this is going to be 26. So now let's clean it up, get rid of the bracket. So you're going to have x squared plus 6x plus 9 plus 25x squared plus 150x plus 225. Then take the 26 to the other side. So it's going to be minus 26 is equals to 0, right? So now we're going to group like terms. So grouping like terms, we see the fact that this and this are going to go together. Then we see the fact that this and this is going to go together. Then lastly, this and this are going to go together, right? So now with that said, is that now let's add everything, right? So if you say x squared plus 25x is the same as saying 1 plus 25, right, which is going to give me 26. So we're going to have here as being 26x squared. Then the yellow one, right, is the same as saying 6, right, plus 150. So 6 plus 150 is going to give me what? It's going to give me plus 156x. Then lastly, we're going to have the blue one. So the blue one is the same as saying 9 plus 225 minus 26. So that you're going to get as plus 208 is equals to 0. So now we're going to take 26 as a common factor. So when we do that, we're going to have 26, then open bracket. So let me just do this. So it's going to be open bracket. We're going to have x squared. Then this side, if you say 156 divided by 26, it's going to give you 6x. And if you say 208 divided by 26, you're going to get s plus 8 is equals to 0. Divide both sides by 26. So this side, you're going to have x squared plus 6x plus 8 is equals to 0 divided by 26. So therefore, we're going to have x squared plus 6x plus 8 is equals to 0. So now let's factorize this, right? So we're going to have two bracket, which is going to be x plus 2, right? And the other one is going to be x plus 4 is equals to 0, right? So now we're going to basically equate each bracket by 0. So it's going to be x plus 2 is equals to 0. Or it's going to be x plus 4 is equals to 0. So we see the fact that x is equals to negative 2, then x is equals to negative 4. Then using your x coordinate, we need to pick which one we need to use. So let's go up. All right. So we see the fact that r is here. And if we're doing using this circle plus this diameter, we see the fact that we have 2 points, right? So that is why we got two values. So where does r lie, right? So we see the fact that here, and I'm just going to use dotted lines. Let me just do this. Use dotted lines. And in red, right? We see the fact that for P, if we go down the dotted lines, do you see the fact that this one is going to be for P, and for R using dotted lines, do you see the fact that it's going to be here? All right. So we see, let me go back to solid. So we see the fact that for P, right, XP is going to be somewhere here. Then XR is going to be here, right? So meaning XR is the smallest between XP. So the smallest one is going to be XR, right? So meaning here, X equals to negative 4 is for XR. So therefore, XR is equals to what? To negative 4, right? So we know the fact that XR is going to be equals to negative 4. So with that said, is that we know the fact that XR is equals to negative 4. To find the complete coordinate, we're going to substitute this here on this diameter, on the equation of the diameter, right? So we're going to substitute. So we're going to substitute XR, which is equals to negative 4, into, right, the equation of the diameter, to get what? To get YR. Hope that makes sense, right? So that's what we're going to do. We're going to substitute into the equation of the diameter to get YR. So when we do that, we're going to see the fact that y of the diameter, so it's going to be y is equals to, remember it's 5x, then it's going to be plus, let's go back, I don't want to make a mistake, plus 19, right? So now we know the fact that YR basically is equals to 5, then it's going to be negative 4, it's going to be plus 19, right? So now we know the fact that that is going to be YR is basically going to be equals to negative 1. So meaning the coordinate of R is going to be what? Is going to be negative 4 is to negative 1. And that's basically how you would find the coordinate of R. So now we're going to do 4.1.4, calculate the coordinate, calculate the value of K. So we're going to go up and see where does K lie, right? So do you see the fact that K is from this equation? And the nice thing is that now we have point R. So we're going to substitute this point R to solve for K. Hope that makes sense, right? So let's go up, right? So we know the fact that K is from here, which is going to be Y is equals to what? Is equals to negative 1 over 5 X plus K, right? So what we're going to do is that we're going to substitute R, right? Which is going to be what? Which is going to be negative 4, negative 1 into Y to solve for K, to solve for K. So now wherever we see Y, we're going to substitute by negative 1, and it's going to be negative 1 over 5, then it's going to be negative 4, then this is going to be plus K. right? So this is going to be the same as negative 1 is equals to positive 4 over 5, right? Plus k. Take that to the other side. So you're going to have negative 1 minus 4 over 5 is equals to k. So therefore, punching that into the calculator, you're going to find your k to be what? To be equals to negative 9 over 5. And that's how you would solve for k. So now we're going to do 4.1.5. It says if OWV is equals to 11.31 degrees, prove that WVSQ is a cyclic quad. So they give us the fact that so O is from here, WV, so this angle here is equals to what? They give us that this angle here, right, is equals to 11.31 degrees. So that's what they gave us, right? And they say that we need to prove the following. We need to prove that WV, so let's do it with another color, orange. So WV, right, WVS, so it's gonna be connecting this two, then S till Q, so it's going to be this one, right? And this, we need to prove that orange part is a cyclic quad, right? So we see the fact that we can draw what? We can draw a butterfly here. So meaning, if I do this, so maybe let me just take my, yes, we can draw a butterfly. Maybe I can do it with a different color. Let's make it in green. So if I draw this like this, connect this, okay, go, yes, okay, so I mean I can draw this as a butterfly, so meaning from here to here, right, and here to here, I can draw this as a butterfly. So let me clean this up. Do you see the fact that the green part creates a butterfly, meaning the fact that this angle here, right, and this angle here needs to be equal to each other. So meaning I need to prove that this is also 11.31 degrees, right? And also that these two are equals to each other. But since we have this as 11.3, I need to prove that this angle is equals to 11.3, right? So what do I have? I have the equation of the line of this. So I'm going to use the tan equals to gradient method, right? So what do I know? I know the fact that if I find this angle here, right, using the gradient, if I can prove that this angle here using the gradient, meaning let's name it theta, right? If I say theta is equals to 10 of this gradient, so it's going to be of this gradient, of this positive gradient, right? It's going to give me, if I can prove the fact that it's 11.3 because of this and this two, right? Using vertically opposite angles, these two are going to be equals to each other. Hope I'm making sense, right? So I'm trying to prove that this angle also is equals to 11.31. Hope I'm making sense, right? So now let's do that, right? So we know the fact that this is going to be theta. So I'm going to let that angle be theta. So I'm going to say, so we know the fact that theta is equals to what? Is equals to, theta is equals to 10, right? Arc10. So this is going to be arc10, right? Arc10 of the gradient, and the gradient of the line is going to be the absolute of the gradient QRST, right? It's going to be that. So before I move on, I want to emphasize something, right? So if we find the gradient, if we're using this method, right? If you're using this method, right? Is that this always going to give us an acute angle, right? So this always gives us the acute angle. That is why we're saying the fact that it's this one. But if we're looking at it, if we wanted the positive, like what you call this angle here, we were going to add plus 180. But because of this formula already gives us the acute angle, that is why automatically when finding this gives us this using the gradient. Hope I'm making sense, right? So with that is that we need to find what is the gradient. We need to find what is the gradient QRST. We know that the gradient QRST, let's go up, right, to the top. We know the fact that that is equals to -5, right? So we know the fact that that is equals to -5. So we know the fact that this is equals to negative 1 over 5. So now let's substitute. So we know the fact that this is equals to 10. It's equals to negative 1 over 5. So why did we say the absolute? The absolute changes anything that was either positive or negative to always positive. So this is always going to be positive. So this is going to be the same as theta is equals to add 10 of the positive 5 over, which equals 1 over 5, right? And when you punch that into the calculator, you find that theta is equals to 11,31 degrees, right? But we know the following. We know that theta is equals to this angle here, the angle that we want, right? We know the fact that theta is equals to that angle. Let's name it. It's OQR. It's OQR. It's equals to OQR, right? And the reason is vertically opposite angles. Vertically opposite angles, right? So since we know that, we know the fact that OQR is equals to 11,31 degrees, right? So therefore, we know that the angle that they gave us, which is OWV, is equals to OQR, which is equals to 11,31, right? So we know that those angles are basically equals to each other. So therefore, we can conclude that WVSQ is a cyclic quad, right? And let's give reasons. And the reason is going to be what? Angles in same sec. So now we're going to do 4.2. It says the radius of the circle, right, having this equation, right, will never exceed root 13 for any value of theta, right? So the first thing is that they're talking about the radius, meaning from this equation, we need to find the radius. Then we can talk about it never exceeding root 13 for this value of theta. Hope that makes sense, right? So now, taking this equation, we know the fact that we have x squared plus y squared plus 4x cos theta plus 8y sine theta plus 3 is equals to 0. So from this, we need to determine our what? We need to determine our r, right? So we know the fact that we can write this in this form, right? So we want to write this. So we want to write the above. We want to write the above in this form, which is what? Which is going to be x minus a all squared plus y. So it's going to be y minus b all squared is equals to r squared. So we want r squared, right? So to do this is that we need to do completing a square. So now we need to group everything with x together and everything with y together, and anything that doesn't have x and y, we're going to put it on the other side so that we can do completing the squared, right? So we know the fact that this is going to be x squared plus 4x cos theta, right? Then we're going to have plus y squared plus 8y sine theta, and this is going to be equals to negative 3, right? So we're going to group this 2 together. We're going to group this 2 together. Then from this is that, remember that completing the squared, what do we need to do? We need to square the one with the coefficient of x, which is in our case, let's write let's write this and this having the coefficient of x, and this one having the coefficient of y. So this one is the same as x squared, right? Plus, I'm going to put x in front, and this is going to be the same. When we take out x, it's going to be 4 cos x, and this is going to be y squared, and this is going to be y. Then this is going to be 8 sine theta, right, is equals to negative 3. Reason why is that I need this to basically first half it, then after halving it, we're going to square it, right? So that's what we need. So we're going to do, let's color coordinate everything so that we know what we're doing. So for this one, it's going to be yellow, and for this one, it's going to be a blue, right? So for the yellow one, right, for x, so we need to do the same thing. The first thing is that we need to halve the one with the coefficient of x, right? So when halving it, we're going to say half, and this is going to be 4 cos theta, right? So that is going to be equals to what? This is the same as 2, so it's going to be the same as 2 cos theta. Then we need to square it, so we need to square it, right? So we're going to halve and square it. Hope I'm making sense, right? So we halved it and we squared it. Hope we're okay with that, right? So now the other one is going to be what? This is going to be for blue. So this is going to be for yellow. Then for the blue one is that we're going to have the one with the coefficient of what? With the coefficient of x, right? So we're going to say what? We're going to say a half, and we're going to say 8 sine theta, which is going to give me what? Which is going to give me 4. So it's going to be 4 sine theta, and we're going to square it, right? So we're going to half it and square it, right? So now let's simplify this. The reason why I'm simplifying it, right? So this is for the blue one. The reason why I'm simplifying it is because I don't care about the coordinate of A and B. I don't care about the coordinate A of B. What I care about is R squared. This is what I want, R squared, right? So our goal is to get R squared. So from here is that we're going to add our yellow here. I'm going to add my yellow here, right? And I'm going to add my blue here. And also I'm going to add my yellow here and blue here to find my R squared. Hope I'm making sense. So this is the same as, let me go back. This is the same as now x squared, right? And this is going to be plus, this is going to be 4x cos theta. And this is going to be plus the yellow one, which is going to be 2 cos theta all squared, right? Then this is going to be plus, then this is going to be y squared plus plus 8y sine theta, and this is going to be plus 4 sine squared, right? 4 sine theta all squared, right? And this is going to be equals to, so let me just move this a little bit here. So this is going to be equals to -3. Then this is going to be plus 2 sine, 2 cos. So this is going to be 2 cos theta all squared plus 4 sine squared, 4 sine theta all squared. Hope that makes sense. So as I said, the fact that what matters is this one, right? What matters is this one, because this is going to be our R squared. And the question is talking about R squared, right? So I'm going to take that R squared. So we know the fact that now R squared is basically equals to -3, right? Then this is going to be plus 2 cos theta all squared plus 4 sine theta all squared. So now we're going to distribute the squared, right? So distributing the squared, this is the same as R squared. It's equals to -3 plus, then this is going to be what? This is going to be 4 cos squared theta, and the side is going to be plus, then this is going to be 16 sine square theta. So now let's simplify this. So we can basically write everything in terms of sine squared theta by substituting an identity here. And the identity that I'm going to substitute, we know the fact that from this identity, so let me just make it on the side. We know from this identity, which is sine squared theta plus cos squared theta is equals to 1, right? So I want to get rid of what? I want to get rid of cos, so I'm going to make it the subject. So it's going to be cos squared theta is equals to 1 minus sine squared theta, right? So I'm going to substitute this identity. So let me just put this inside this block, right? So I'm going to substitute cos squared theta by 1 minus sine squared theta. So it's going to be r squared is equals to -3 plus 4. Then it's going to be 1 minus sine squared theta. And this is going to be plus 16 sine squared theta. Right? So let's go up and clean it further. So now we're going to distribute the 4. So it's going to be r squared is equals to -3 plus 4, right, minus 4 sine squared theta, and this is going to be plus 16 sine squared theta, right? So sine squared theta is a common factor, so we're going to group like terms. So what I mean is that these two are together with the negative, and also these two are together, right? Because they're just numbers. So now let's clean this up. This is going to be the same as having r squared. It's equals to 1 plus 12 sine squared theta. So now we found r squared, and like now we're going to circle back to the equation. We know that we're proving that the radius, and that is why we needed to simplify this by finding r squared, which is going to be our radius. Hope that makes sense, right? So now we're going to go back to the second part of the equation. It says the radius should never exceed, right, root 13 for never exceed root 13 for any value of theta. So for any value of theta. So I'm going to translate this into variable, right? So what does it mean? So never exceeds, right? Never exceeds. So we're looking for never exceeds, right? Never exceeds, meaning if you think about it, never exceeds is finding the maximum. So it's finding the maximum value that it's going to be basically it's going to take for any theta. That is the maximum value, right? So we're looking for that maximum. So never exceeds. So never exceeds, right? Translated is basically r squared is less than and equals to what? To the maximum boundary. So the maximum part, right? So the maximum boundary, right? So now the question is, how do we calculate the maximum boundary, right? So now calculating the maximum boundary, right? We see the fact that here, this is a number, this is a number. The problem is this one, right? So to calculate the maximum boundary, we need to find what is the maximum of this one, right? Then substitute that maximum, then everything's going to be numbers. Then we can basically, we can basically substitute here, right? So finding the maximum boundary of sine squared theta, right? So we know the fact that sine squared theta is what? Is a trig function. So to find the maximum, we're going to use what? We are going to use the range, right? We're going to use range. Reason why we're going to use range is because of range, right, is made out of what? Y is equals to, is made out of the minimum and the maximum value. And we want the maximum, which is this one, right? So now we need to find the range of sine squared theta. So I'm just going to give you what is the range. So the range of sine squared theta is always going to be y is an element between 0 and 1. And reason for that is normally, right? So normally, and I'm just going to erase this. Normally, the range for sine theta is between what? Is y is between -1 and 1, right? But the square root makes everything that is negative positive, right? So that is why now the range is between 0 and 1. Hope that makes sense, right? So with that case is that the maximum boundary, so the maximum boundary, right, of sine squared theta is equals to positive 1. So now with that said is that we know the fact that r squared is going to be equals to what? It's going to be equals to 1 plus, so it's going to be, so basically what I mean is that the maximum boundary now, the maximum boundary, so let me just do this so there is consistency. So I'm going to take this, right? I'm going to take this, duplicate it and cut it. Yes. So I'm going to paste it here, right? So now the maximum boundary of this one, the one that of the whole question, so the maximum boundary, so the maximum boundary, right, is basically equals to 1. So it's going to be 1 plus 12. So it's going to be 1 plus 12. Then sine squared theta is going to be replaced by 1 because we know the fact that it's 1, right? For sine squared theta is going to be equals to 1. So therefore, the maximum boundary here is going to be equals to 13. So now let's substitute. So therefore, r squared is less than and equals to what? Is equals to 13, right? So square root both sides. So it's going to be r is less than and equals to square root of 13. So which proves the fact that it will never exceed what? That proves this question, which is the fact that it will never, r will never exceed root 13 for any value of theta. Hope that makes sense, Anna. So now we're going to do trigonometry. We're going to start with the first question. Question 5 says, given that cos 16 is equals to k, without a use of a calculator, determine the values of the following in terms of k. So we're going to use what? We're going to use the Cartesian plane, right? So now using the Cartesian plane, so we're going to draw a Cartesian plane, right? Using the Cartesian plane, it's going to be like this, right? So first we need to determine where our cos 16 is, right? So is it going to be, we know the fact that since this is positive, it needs to be positive, and where is cos positive? Cos is positive in the first and in the fourth quadrant. So this is all students take coffee, right? So cos is positive here and here. And then remember the fact that our triangle can't be in 2 quadrants. It needs to be in 1. But we see the fact that they tell us the fact that the angle is 16. So the reference angle needs to be 16. So the angle here, it's 16. So 16 is between what? It's an acute angle. So it's between 0 and 90 degrees, right? Since it's between 0 and 90 degrees, meaning our triangle is going to be in the first quadrant. So now let's draw the triangle in the first quadrant. So it's going to be like this, right? So that's what we're going to have, right? So we know the fact that this is going to be 16 degrees and this is going to be what? It's going to be 90 degrees. Then now we need to find this remaining angle. So we're going to call that angle theta, right? So finding that remaining angle is that you'll see the fact that as we answer the rest of the questions, this angle could help us, right, to answering one of the questions. So now let's find that angle. So we know the fact that angle theta plus 16 degrees plus what? Plus 90 degrees needs to be equals to 180 degrees. And what's the reason for that? That is sum of angles in a triangle. So sum of angles in a triangle, right? So now solving theta. So it's the same as theta is equals to 180 degrees minus 16 degrees, right? Minus 90 degrees, right? So we see that theta is basically equals to 74 degrees. Hope that makes sense, right? So I'm just going to replace this by 74 degrees, right? So it's going to be 74 degrees, right? So it's going to be 74 degrees. So now, since they gave us this in terms of the angle, we filled in all the angles that we need. Now we need to fill in all the sides that we need, right? So we see the fact that cos is what is equals to k. So this is the same as having what? This is the same as saying cos 16 degrees is equals to k divided by 1. So we know the fact that cos is adjacent over hypotenuse. So 16 is here, right? So 16 is here. It's here. So meaning using that as reference, adjacent is going to be here, then hypotenuse is going to be here, right? So we know the fact that adjacent is going to be here, then hypotenuse is here. So this, right, represents x because it's in the x-axis, and this represents y because it's parallel to the y-axis, and this is r, right? So we see the fact that we need to solve for what? We need to solve for y, right? So using Pythagoras, right, it's going to be what? The formula says r squared is equals to x squared plus y squared. We know r squared is 1, right, all squared. Then x squared is k all squared. Then y squared is what we're looking for, right? So now let's solve. So this is going to be the same as 1y minus k squared is equals to y squared, right? Then we see the fact that our y is in the positive. Do you see the fact that it's in the positive? So when doing the square root, you know the fact that you need to take the positive, right? So when you put the square root on both sides, so it's going to be 1 minus k squared. Let's just say plus or minus, right? Because plus or minus because of this is an even number. So this is equals to y, right? So therefore, y is basically equals to what? It's equals to either the negative, right? 1 minus k squared, or the positive, right? So it's going to be 1 minus k squared, right? So from that is that we see the fact that, as I said, the fact that it's in the positive. Ooh, let me just erase this, I'm sorry. Yes, so we see the fact that it's in the positive, right? So therefore the answer is going to be the positive one. So therefore y is basically equals to the square root of 1 minus k squared. So we know the fact that this side is going to be square root of 1 minus k squared. Hope that makes sense, right? So now we have filled in the entire diagram. We can go and answer the first question. So now we're going to do 5.1.1, right? It says it's looking for sine 344. So now looking for that is that we need to match up this 344. We need to reduce it to either look like 16 or to look just like 74 between the two, right? So we see the fact that if what you call this 344, so we see the fact that 344, right, when reducing it, and when reducing it is that it's either we use what you call this, it's either we use 180, 360. So 180 should be part of what we're reducing it, right? It's either you add or subtract by 180, add or subtract by what you call this 360, add or subtract by 90. That's the two. That's the three things that we need to see, right? I hope I'm making sense. So we see the fact that 344 is the same. It can be rewritten as 360 minus 16, right? So when you subtract this, you get exactly this. So meaning I can replace sine 344 by what? By sine 360 minus 16, and this is reduction, right? So since now it's reduction, we're going to use the reduction diagram, right? So with the reduction diagram, sine 360 minus 16, so 16 is now like represented by theta, right? We need to find this. So we see the fact that if we go to the diagram, 360 minus is here, and 360 minus theta, right, is the same as minus sine theta. So theta is 16. So this is the same as what? This is going to be the same as it's equals to minus sine 16, right? So sine 16. Now we're looking for negative sine 16. We see that negative sine 16 is what? Sine is opposite over hypotenuse. So this is the same as the, what you call this, the square root of 1 minus k squared, right, divided by 1, right? So this is the same as the square root of 1 minus k squared, right? So let me just do this, right? Divided by what? Divided by 1, right? So this is basically the same as the square root of 1 minus k squared. Hope that makes sense. So this minus the square root of 1 minus k squared. So that's how you would answer this question. So now we're looking for 106. Same applies with how we did the first one, is that we need to reduce it to either be 1016 or 74. And it's either we're going to use that by adding or subtracting by 360, adding and subtracting by 180, right? Since we're using 10, we only have two options, adding or subtracted by, what you call this, 16 or 180, right? Hope that makes sense. So we see the fact that 10, right? So 106 can be written as what? As 180 minus what? Minus 74, right? So we see that. So we can replace 10, 106 by what? By 10, 180 minus 74, right? Again, is that when we subtract this, we get exactly this. Hope that makes sense, right? And that's reduction again. So we're looking for 10, 180 minus, right? So 10, 180 minus is in the second quadrant, so it's going to be negative, right? So the fact that we know the fact that that's negative, so this is going to be the same as what? This is going to be the same as 10 minus 1074, right? So that's what we have. So now we're going to go to the diagram and find what you call this 1074. We see the fact that now this is our reference angle. So this is going to be what? 10 is opposite over what? Over adjacent. So it's opposite over adjacent. So it's going to be K divided by this, right? So we're going to have what? It's going to be equals to minus, open bracket, it's what? It's K divided by square root of 1 minus K squared, right? So this is going to be the same as what? So let me just zoom it in. This is the same as minus K divided by the square root of 1 minus K squared. Hope that makes sense, right? So now what we're going to do, we're going to do this question, right? They say the 1 cos 8, right? So as I said, the fact that looking at the diagram is that when solving, it's either we need to find 72 or 16. But what do we know? We know the following, right? We know the fact that 16 is equals to 2 multiplied by 8, right? How is this 2 multiplied by 8 is going to come in handy? How is this 2 multiplied by 8 is going to come in handy? Because of this identity. We know the fact that cos 2 theta, right, is equals to what? Is equals to 2 cos squared theta minus 1, right? So now using this identity, right, we're going to rewrite this in this form. So it's going to have 8 in it. So we know the following. We know the fact that if I find cos 2 multiplied by 8, which is 16, right? Which with this 16, we can find it using the diagram. Hope I'm making sense, right? If I rewrite this, and I'm just going to put it like this, right? Sorry, it's going to put it like this, right? It's going to be what? It's going to be 2 cos squared 8, right, minus 1. How is this nice? Is that, remember the fact that the goal is to find this and we have it here. So do you see the fact that I can basically make this the subject of the formula, because of we know the fact that this is 16 and we already know we already have 16 in the diagram. So now let's clean it up. This is the same as cos 16. So this is cos 16 is equals to 2 multiplied by cos squared 8 minus 1. So make cos 8 the subject because that's what we're solving. So this is going to be cos 16 minus 1 is equals to 2 multiplied by cos squared 8, right? So now it's going to be cos 16 minus 1, and this whole thing is going to be divided by 2 is equals to cos squared 8, right? So now we know the fact that this is the same as cos 16 minus 1, right? And this thing is divided by what? This thing is divided by, this is divided by 2. Then we're going to square root both sides. So we're going to square root both sides because we want to get rid of the squared. So this is the same as having cos 8 all squared and square root it like this, right? So now this side we're going to have what? We're going to have cos 16 minus what? Minus 1 divided by 2, right? Square root is equals to cos 8, right? So now we need to get rid of this one, cos 16, right? So going back, we know the fact that cos 16, let's check. We know the fact that cos 16 is what? Is equals to k, right? Cos 16 is equals to k. So go up. We're going to replace cos 16, but let me just say here, but we know that cos 16 is equals to k. So this is the same as having the square root, right, of k. So it's k minus 1 divided by 2, right, is equals to cos 8. And that's how you would solve this question. So now what we're going to do, we're going to do 5.2, which is, without a use of a calculator, simplify the following into a single trig ratio. So this is reduction. So this is the diagram that we're going to use, right? So I'm going to take individual of them, right, solve them separately individually, then we're going to substitute it back, right? So now we're going to start with the first one, which is going to be what? Which is going to be cos. So this whole thing, okay, let's just do it like this. Before even substituting, I'm going to take this and write it in a way that we could solve it properly. So we know the fact that we have cos. So let me just rewrite it, cos squared. Then this is going to be 180 plus x, right? Then this is going to be the square bracket. Then it's going to be 10. Then this is going to be 360 minus x multiplied by cos. Then this is going to be 90 plus x. Then it's going to be plus sine. Then it's going to be x minus 90, right? Then this is going to be multiplied by cos 180, and this is going to be square bracket, right? So I want to sort out this one first before even taking the individual. This is the same as having cos 180 plus x into a square bracket on its own, all squared. Then just rewrite this whole thing, which is going to be 10 360 minus x. Then this is going to be cos 90 plus x, and it's going to be plus sine x minus 90. Then lastly, it's going to be cos 180, then square bracket, right? So now taking as them as individual, right? I don't think we need to take them as individual. So this, right, this one, maybe let's color coordinate it. Yes, let's color coordinate it. We know the fact that this, right, if we go to the diagram, is the same as cos 180 plus, so 180 plus cos 180 plus. So cos 180 plus is going to be this one. So we know the fact that that is negative. So that's going to give me negative. So this is going to be square bracket negative cos x all squared, right? So we have color coordinated it. Then the next one, which is going to be this one, right, which is 360 plus. So 360 plus 360 minus, sorry, 360 10 360 minus, it's going to be here. So we see that it's negative, so it's going to be minus 10, and this is going to be x, right? Then this multiplied by cos, so color coordination. So this is going to be blue, so it's going to be here 90 plus, so 90 plus, so 90 plus 90 plus cos 90 plus is going to be this one. So it's going to be minus sign. So it's going to be minus sign. So put it in here. It's going to be minus sign x, right? Then this one, we need to rearrange how it's written. So let's first rearrange how it's written. So this is going to be plus sign. Your x always is the second one. So let's rearrange it. This is the same as having what? This is the same as having negative 90 plus x, right? And lastly, 180 is a special angle. So in your calculator, right, if you say cos 180, it's going to give you -1, right? So I know they said without the use of a calculator, but we can cheat a little. So it's going to be -1, right? Then square bracket, right? So now we know the fact that who's missing is this one. So let's go back to color coordinating everything so that you see. We know the fact that this is this one, right? This one is this one. Go back. We know that yellow is this one. Blue is this one. Then we left with this. So let's sort out this one, right? So now let's continue sorting it out. So I'm going to sort it out here. So we know the fact that we have sine. So we know the fact that we have sine 90, right, plus x, which is the same as what? Which is the same as So which is the same as, now pull out the negative because this one can never be negative, should never be a negative number. So when we pull it out, it's the same as having sine. So it's the same as having sine, square bracket, take out the negative. So it's going to be negative. Everything was negative becomes positive. Anything that was positive becomes negative. So it's going to be 90, right? Minus x. So it's going to be like this. Then this, right? You see that this is going to be the same as applying this, right? So now let me just highlight it. We are color coordinating everything. So we know the fact that this is the same as applying which one? As applying this one, right? Where this is your whole theta, right? So that's your whole theta. So this is going to be minus sine. So this is going to give you what? This is going to be equals to minus sine. And this is going to be 90 minus x, right? And now applying what? So we have green, so orange, right? Applying this one, right? We're going to apply it where? We're going to 90 minus. So 90 minus sine, 90 minus is going to be this one. So it's going to be cos, positive cos. So this is going to be, since it's negative, it's going to be minus. And this is going to be cos x, which is the same as minus cos x, right? So this is going to be basically replacing the 1, right? So now that is going to be equals to, I forgot to put equals to, don't be like me, don't forget to put your equals to, right? So now let's do this because we like order, right? So let me just put this inside, not a, maybe like a blue block. Yes, right? So now it continues after the blue block. So we know the fact that we have let's simplify this. So let me just erase this. So when we simplify the green one, right, since it's square and it's a negative, that's going to make it a positive cos. So that's going to be positive cos squared x, right? Changing, distributing the negative. So the negative is going to come here. It's going to make this positive and it's going to come here. Hope that makes sense, right? Then putting in the square bracket, we're going to have minus 10. So we know the fact that we're going to have minus 10 x, right? Minus 10x multiplied by what? Multiplied by, this is 2 square brackets. Yes, because we simplified. Yes, it's 2 square bracket. So it's minus 10x. And it's going to be minus sine x, right? And this is going to be plus. This is going to be replaced by minus cos x. Then minus 1. Square bracket. So let's clean up the square bracket. So we know the fact that that's going to be cos squared x. Then here it's going to be negative, and negative is the same as 10x multiplied by sine x. Then here a negative and a negative gives me a positive. So this is the same as plus cos x. Then here we're going to apply the identity, right? So we're going to apply the identity. So we know the fact that the identity is going to be cos squared x. Then here it's going to be what? It's going to be sine x divided by cos x, right? And this is going to be multiplied by sine x. And this is going to be plus cos x, right? And this is going to be that. So now let's clean this up, right? We know the fact that this is going to be numerator to numerator. So this is the same as cos squared x, right? And this is going to be sine squared x divided by cos x plus cos x, right? So now looking at the square bracket, we're going to find the LCD, right? So finding the LCD, this is the same as cos squared x, right? So this is going to be the same as this. So this and this multiplying together and this by 1. So basically, let me just write it like this so that you can see. We know the fact that this is sine squared x and this is cos x. Plus this, we can write it as cos x divided by 1. Right? So now finding the LCD is doing the following. Is that we're going to multiply this and this together, this and this together, and finally this 2 together. So this is the same as having, So this is the same as having cos squared x, right? Square bracket, this is going to be sine squared x multiplied by 1 plus cos x multiplied by another cos x, and that whole thing is going to be divided by cos x multiplied by what? Multiplied by 1, square bracket. So let me just go up, clean it up further. So this is going to be cos squared x, right? And this is going to be the same as what? As sine squared x, right? Plus cos squared x, and this whole thing divided by what? Divided by cos x, and it's going to be square bracket, right? So now we know the fact that this is an identity. This is an identity, right? And that identity, I'm just going to write it here. We know that sine squared x plus cos squared x is equals to 1, right? So we know that that is equals to 1. So let's put that down. It's acting. So that is equals to 1. So let's put it down here, right? So now we're going to replace it here. So we know the fact that this is equals to cos squared x. And this is going to be basically 1 divided by cos x, right? So now multiplying, so this is the same as cos squared x divided by cos x, which is the same as having what? As having cos x multiplied by cos x. I'm splitting it up so that you can see how we divide in the denominator. So this is going to be the same as cos x. So this and this is going to cancel out. So therefore, you're going to be left with just cos x. And that's going to be your final answer for this question. So now we're going to do 5.3. It says, given that this and this, right, we need to prove the identity. So we see the fact that here, the most complex side is going to be the left-hand side. So let's go up. We know the fact that this is the left-hand side and this is the right-hand side, right? Proving an identity, we're proving that the left-hand side is equals to the right-hand side. The most complex side is the left-hand side. So let's take the left-hand side. So we see that the left-hand side is equals to cos 3 theta plus cos 7 theta, right? And that is divided by what? That is divided by cos 5 theta, right? So now looking at it, we need two things. We see the fact that the denominator is 5 theta, right? So meaning when we reduce this 2, we need to have 5 theta in it. And again, we see the fact that what we're trying to prove has 2 theta. So we kind of need to arrive to something that has 2 theta. But what do we know? But we know that we can rewrite this 2 with having both 5 theta and 2 theta. But we know the fact that 3 theta is the same as what? Is the same as 5 theta minus 2 theta. Having two things that we want. This and this. Hope that makes sense. And also 7 theta can be written as 5 theta and 2 theta. So it's going to be 5 theta plus 2 theta. But we know that. So now let's replace our 5 theta and 3 theta, right? So we know the fact that now, so we know the fact that this is going to be basically, let me just put this in a square. Blue, yes. So that is going to be equals to what? We know the fact that that is basically equals to cos, and this is going to be 5 theta minus 2 theta, right? Plus what? Plus cos, and this is going to be 5 theta plus 2 theta. And this whole thing is going to be cos 5 theta, right? So now we're going to apply our identity here. So we're going to apply our identity, right? So we're going to apply this identity. Do you see the fact that for the one that's positive, you just change the sign, and the one that's negative, you just change the sign? So we're going to apply it here. So we're going to start with this one, which is going to be equals to what? Which is going to be cos, and it's going to be 5 theta, right? Multiplied by cos 2 theta, right? Is it's, since it's what? Since here it's negative, it's going to be plus. So let's put it in this bracket. is going to be plus sine 5 theta multiplied by sine 2 theta, right? Put that inside the bracket, and we're going to deal with the one with the positive. So it's going to be plus, and this is going to be cos 5 theta multiplied by cos 2 theta, right? And this is going to be what? This is going to be minus, because of the sign is positive. So it's going to be minus, and we're going to have sine 5 theta, like 5 sine and sine 2 theta. Then this whole thing is going to be divided by what? Divided by cos 5 theta. Right? So now let's clean up the numerator. So we know the fact that we're going to have cos 5 theta multiplied by cos 2 theta. It's going to be plus sine 5 theta multiplied by what? Multiplied by sine. Actually, I don't need to rewrite it because of this bracket. I'm not going to get rid of the bracket. This positive is not going to affect anything. Let's just highlight grouping like terms, right? So we see the fact that this and this are basically the same thing, right? And we see the fact that this and this are basically the same thing. So we see that the orange one, both of them are positive. So this is the same as saying 2 of them, right? So it's adding 2 of them. So this is going to be the same as 2 cos 5 theta multiplied by cos 2 theta. Then we see that the yellow one is positive and the other one is negative. So this cancels out to being 0. Hope that makes sense. So this whole thing is now going to be divided by cos 5 theta. So we know the fact that now this and this are going to cancel out. So you're going to be left with what? With 2 cos 2 theta. And that's going to be your answer for this. Let's check whether does it match with the right hand side. And this matches up with the right hand side, which proves the identity. So now we're going to do 5.3.2. It says, hence, determine the value of this without the use of a calculator. So what is our hence? So I'm going to say hence is taking whatever that we found previously, right? So hence in our case is, we know the following. We know the fact that the left hand side, so hence, meaning what we were proving, we know that this, so duplicate it, right? We know that the left hand side, which is this, right, is equals to what? Is equals to the right hand side, which is 2 cos 2 theta, right? So we see the fact that the left hand side looks exactly like this, right? Do you see the fact that it looks exactly like this? And basically to solve it, we're going to just use this because of this, the simplified version. So that is our hence. So we know that this is our hence, right? We know the fact that this is our hence. Let me just make it in blue, right? So since this is our hence, we need to solve to find this in its value. We need to find what's theta. So like looking at this, we see the fact that we have the full value. So everything is in terms of theta, but it has a multiple in front of it. We have 5, we have 3, we have 7. If we look at the numerator, it's hard to find which one is it. But the easiest one is the denominator because it only has 1. Right? It has only 1 cos. So we can take this one, right, and divide it by 5 to find theta. So first, finding theta, right? We can say what? We know the effect that we know. So we know that. So we know that we know that we know that 5 theta, right? So we know the fact that 5 theta is equals to what? We know that 5 theta is equals to 112.5, right? Because of what I did is that I equated this and this together. Hope that makes sense, right? Maybe because I think I like the highlighted, this and this are equals to each other. We know that, right? So from that, you know the fact that we can solve for what? We can solve for theta, right? To solve this thing, right? So we know the fact that that's going to be 112.5, right? So theta is basically equals to 112.5 divided by 5, right? So we know that. So now when we punch that into the calculator, obviously they're not going to know that you used the calculator. We see the fact that theta is going to be equals to what? If you punch that into your calculator, if you say 5 divided by 1112 which was 1112 comma 5, you're going to get the fact that you're going to get 22. So you're going to get 22 comma 5. And just to check whether that's the correct theta, right? Just to check. So checking. So we know that theta is that. Checking that is correct. Checking that is correct. That it is correct. We can test it out with finding what? With finding 7 theta and also finding 3 theta, right? So if you say 22, so if you say 7 multiplied by 22 comma 5 degrees, and also here if you say 3 multiplied by 22 comma 5 degrees, you'll find the fact that for 7 multiplied by 22 you're going to get 156. So you're going to get 157, right, comma 5. Try it on your calculator. And also the other one you're going to get what? 67 comma 5. So 67 comma 5, 67 comma 5, which is exactly what we have here, right? So since we know the fact that theta is equals to that, so therefore we know that 2 cos, so it's 2 cos 2 theta, so it's 2 cos 2 theta is the same as 2 cos 2, then this is going to be what? 22 comma 5 degrees, right? So that is going to be basically what? When you add that into your calculator, right, you're going to get this as being 2 cos, when you say 2 multiplied by what? 2 multiplied by 22,5, you're going to get it as 45. That is a special angle, so that is the same as 2. When you punch this one into your calculator, just this one, or using a triangle, you're going to get this as being square root of 2 divided by 2. And that is the same as what? This is the same as square root of 2. So that's how you would solve this question. Okay, now we're going to do 5.4, which is determine the general solution. So we are given this and we need to solve for x, which is solving for the general solution. So already, since it's within 2 brackets, we can equate each bracket by 0 and solve for each, right? So we know the fact that this is going to be the same as 4 sine 3x plus 1 is equals to 0. Or the other one is going to be sine x minus 5 cos x is equals to 0, right? So we know the fact that this side, we're going to make the trig ratio the subject, right? So now solving, solving for sine 3x plus 1 equals to 0. So now taking the 1 to the other side, you're going to have 4 sine 3x is equals to negative 1. So dividing both sides by 4, so it's going to be sine 3x is equals to negative 1 comma 1 over 4, right? So now finding the reference angle. So finding the reference angle, it's going to be equals to arc sine. So it's always going to be what? This, then there's the positive value. We do not care about the negative. Do not put the negative. So it's going to be arc sine of 1 over 4, right? So when you find the reference angle, so this reference angle is going to be basically equals to 14 comma what? 14,48. So now writing your solution, you're going to use this diagram. So how do you know where your solution lies? It's dependent on this negative sign, right? So we see the fact that we're looking for when sign is negative. Where is sign negative in our case? Sign is negative in the, let me just take my highlighter. So we see that sign is negative where? It's negative in this third quadrant and also negative in the fourth quadrant, right? So now writing our solution. But very important, you see the fact that our angle in our case is 3x. So it's going to be this equating by whatever you picked here. Hope that makes sense, right? So it's going to be what? It's going to be for quadrant. So for quadrant, so we know the fact that our solution is quadrant 3 and quadrant 4, right? So for quadrant 3, so we know the fact that for quadrant 3, right? So we have the following. We have that 3x is equals to what? Is equals to 180. So it's going to be 180 plus the reference angle. So it's going to be 14,48, right? And this is going to be what? Plus K 360 degrees, right? So now let's clean this up, right? So when we clean it up, we know the fact that this is going to be the same as 3x, right, is equals to 194, what, 48 plus k, then this is going to be 360 degrees. Then we want x alone, right? So we want x alone. So we want x alone. So we're going to divide this and this by 3. So this is going to be the same as x is equals to 104,48 divided by 3. It's going to be plus k. That's going to be 360 divided by 3. Clean that up further, right? So therefore, x is going to be equals to what? X is going to be equals to 64,83 plus k. Then this is going to be 120, right? So that's going to be your first solution. Then the second solution is in quadrant 4, right? So in quadrant 4, so we have quadrant 4. We see the fact that's going to be 3x and 3x this, right? So it's going to be 3x is equals to the reference angle. So in our case, our reference angle is going to be minus 14, what? Minus 14,48, right? It's going to be plus k 360, right? So this is going to be the same as x is equals to minus 14,48 divided by 3 plus k, then it's going to be 360 divided by 3. So in your calculator, right? So in your calculator, when you say the following, if you say 14,48 divided by what? Divided by 3, you're going to get your answer as being x is equals to negative 4,83, right? And this is going to be plus k, and this is going to be 120, right? And that's going to be your solution for this too. So let's highlight those solutions so far. So we know the fact that this is our solution and also this is our solution, right? So now we have sorted out this one, right? Maybe let's underline it so there's some consistency. We have solved this one. Now we're going to move to this one, right? So now solving, so go up, solving, so solving. So the next one is what? It's sine x minus 5 cos x, so minus 5 cos x is equals to 0. So it's equals to 0, right? So now with that is that when we solving this one, right? Do you see the fact that both of them, so let me just erase this. So do you see the fact that there's x and this is sine and this is cos? There's an identity that we can apply. So what I'm going to do is that I'm going to take the cos x, I'm going to take the 5 cos x to the other side, right? So first thing, so let's underline this. So we know the fact that sine x minus 5 cos x is equals to 0. We know the fact that this is the same as having sine x is equals to 5 cos x, right? Then what I'm going to do is that I'm going to divide both sides by cos x. So if I divide both sides by cos x, so if I say sine x divided by cos x is equals to 5 cos x divided by cos x. We see that the cos x are going to cancel out, and this is going to give me 10 x is equals to 5. And that's perfect because of now I can use 10 to find the reference angle. Hope that makes sense. So since now I have that, now let's find the reference angle because it's a single trig ratio. So let's find the reference angle. So we know that the reference angle is equals to what? Is equals to, so it's going to be equals to arctan. So it's going to be arctan of this number. So it's going to be arctan of 5, which we're going to get our reference angle as being what? As being 78,68. So now we're going to go to the diagram and ask ourselves, where is 10 positive? Because this is positive 5, right? So we see the fact that it's positive in the first and the third quadrant. So let's highlight that. So we know that our answer is this one, and go back, I hate this. So it's going to be yellow. So we know the fact that's going to be here and here, right? So now with that is that we're going to know for quadrant 1. So quadrant 1, we know the fact that, do you see the fact that here our x is 3, it's just x, right? So our answer is going to be x is equals to, the first quadrant is just the reference angle, so it's going to be 78,69, right? Plus, then there's going to be k3. We're dealing with 10. Very important, since we're dealing with 10, it's going to be multiplied by 180 degrees, right? So that is going to be for quadrant 1. Then we know the fact that the second solution is quadrant 3, which is going to be x is equals to, quadrant 3 is going to be 180 plus, so it's going to be 180 plus the reference angle, which is 78,669, so it's going to be 69 plus k, and this is going to be 180 degrees, right? So we know the fact that therefore x is going to be equals to what? It's equals to 258,669. So it's going to be 69 plus k, then this is going to be 180 degrees, right? So that is going to be our solution. Then at the end, you can say the fact that k needs to be an element of integers. And what I'm going to do is that I'm going to highlight the final answers in green. We know the fact that this is our final answer here, and this is our final answer. So our final answer is the one that I've highlighted. Hope that makes sense. So that's how you would solve this question. So now we're going to do question 6. It says, in the diagram below, f of x is equals to negative 2x, right? Then they tell us the interval that we're looking for. Then the second part is that they say the fact that, so they give us the graph of f. Then they say the fact that on the same system of x's in the answer sheet sketch, then they want us to sketch this, right? So now looking at the sketch before even starting, I just want to check what is the interval between here so that I can know what is going to be interval in my calculator. So we see the fact that here it's 0, then it's 1, 2, 3, right? So it's going to be 1, 2, 3. So meaning this is going to be divided by 3 so that we can know what comes here and here. And we see the fact that that is going to be what? That is going to be 30, right? So we know the fact that this is going to be 30 and this is going to be 60, then it's going to be 90, right? So when you say 90 plus 30, so if you say 90 plus 30, so if you say 90 plus 30, you're going to get what? You're going to get 120. So it's going to be 120 here. Then here's going to be 150. Then it's going to be 180. Then it's going to be 180. 180 plus 30. It's going to be 210. And this is going to be 240. Right? So now doing the other side but just negative, it's going to be negative 30, negative 60, it's going to be negative 120. So we know the fact that our interval, looking at it, is what? It's 30, right? So now using that information, that's how we're going to enter our intervals so that we know the fact that we have all the intervals in the graph. So to sketch this, I'm just going to use my calculator to do that. So now we're going to do g of x in the calculator. So the first thing you're going to say mode. Then you're going to look for something that says table. In my case, it's 7. So I'm going to say 7. Then I'm going to put in my sign. So it's going to be sine, right? Sine, then it's going to be alpha. Then it's going to be x, right? Then it's going to be plus 60. Then close. And we're going to say equals to. We do not have a second graph. So this is basically equals to. Then where are we starting? We're starting at negative 120. And we're going to be ending at 240. Then steps. Remember when I get the interval on the graph? So we know the fact that our intervals are 30 because that's what we've been adding to get our next value. So it's going to be intervals of 30. And this is going to be how it's going to look, our table. And we're just going to copy and paste this table, and we're going to just sketch this graph. So now here's the table, right? So with the table, we see something. We see the fact that we have a negative 0.8, and we also have a positive 0.8, and we have a negative 0.5 and a positive 0.5, and we have positive 1 and negative 1, right? So with that is that the 0.5, we see the fact that it's going to be between 0 and 1, so that is visible. But for 0.8, positive 0.8, I did a dotted line and put it there. And also here, I did a dotted line and put it there. So that when putting out the points is very easy, right? So with that said, now let's put in the points, right? So we see the fact that it's negative 120 and negative 0.8, which is going to be here. Then we have 90 and 0.5, which is going to be here, right? Then it's going to be 60 and 0, so it's going to be here. And we see the fact that it's 30 and 0.5, which is going to be here. Then it's going to be 0 and 0.8, which is going to be here, which is the x-axis, y-axis, sorry. Then it's going to be 30 and 1, so it's going to be here. Then it's going to be 60 and 0.8, so it's going to be here. Then it's going to be 90 and 0.5, so it's going to be here. Then it's going to be 120 and 0, so it's going to be here. Then it's going to be 150 and 0.5, so it's going to be here. Then it's going to be 180 and what? 180 and negative 0.8, which is going to be this one on the dotted line. 110 and negative 1. Then lastly, 240 and negative 0.8. So now what we're going to do, just join the dotted line. So joining the dotted line, it's going to be just like this. This. Okay, cool. It's just going to be, so it's going to be like this. So that's how you would draw the graph. Hope that makes sense. So now we're going to do 6.2, which is 6.2.1, finding the period of g of x, right? So now let's go find g of x. We know that g of x is equals to, so let's go up. We know the fact that it's sine, open bracket, let's make sure it's sine, open bracket, x plus 60. So we know the fact that finding g of x, we need the coefficient of what? Of x. And we see that our coefficient of x is 1, right? So we see that b is equals to 1. So therefore, the period, right, is equals to 360 divided by 1, absolute of 1, which is the same as 360. Absolute of a positive number is still positive, so it's going to be 1. So our period is going to be just 360. So that is the period for this question. So now we're going to do 6.2.2, right? We need to find the range of this. So what I'm going to do is first find the range of f of x, then after find the range of f of x minus 3. Because we're going to need the range of f of x. So finding the range of either a cos and a sine, this is what we're going to use, right? So we're going to take f of x. So we know that f of x is equals to, let's go up and check what f of x is equals to, is negative 2x. So it's going to be negative 2 cos x. Let's go up, right? Yes. So that is going to be what? That's our f of x, right? So now finding the range. So we know that finding the range is going to be y is an element of negative absolute of a, right? Plus q. Then it's going to be absolute of a plus q, right? So that is going to be that. So we need our a. So we see that our a, in our case, our a is the coefficient of the trig ratio. So in our case, it's going to be negative 2. And q is the number after. So it's the number after. So we see the fact that there is no number after. So that's going to be equals to 0. So now we know that y is going to be in an element of negative. Then it's going to be negative 2 plus 0. Then it's going to be 2 negative 2 plus 0, right? So y is going to be an element of negative, then absolute of any negative number becomes positive. So this is going to be the same as 2 plus 0, and this is going to be 2 plus 0. So now let's clean this up, square bracket. So y is going to be an element from negative 2 till positive 2, right? And this is the way of solving it, but you could have just used the graph, right? You could have just used the graph. You see the fact that the minimum, the smallest value is here and the biggest value is here. But I think it's good to know it, how to solve it like this. Hope that makes sense, because sometimes it's not all the case that they're going to give you what? They're going to give you the graph. Hope that makes sense, right? So now we know the fact that this is the range. So this, so range for f of x is equals to what? Is equals to y is an element from negative 2 is to positive 2. So now we're looking for range, right, of f of x. So it's going to be for what? For f of x minus what? Minus 3. So this 3, hate when this happens. So this 3 affects the y. So meaning, since we're looking for the range, is that we're gonna add a negative 3 here and a negative 3 here. So that's gonna be the same as y is an element. It's gonna be negative 3. It's negative 2 minus negative 3. It's gonna be 2 minus negative 3. So therefore, our range for this one is going to be minus 5 is to what? Is to negative 1. So that's going to be the range. So that's why I'm saying find this range, then change this range by basically modifying what we had here. So that's how you would find the range for this question. So now we're going to do 6.2.3. It says... So it says the number of solution, meaning solving for x, right? Given that f of x is equals to g of x. So they're saying the fact that when solving this, which is the intersection, equating where both the graphs are touching each other, how many solutions are there? We see the fact that the intersection happens here. So I'm just going to do it in orange. Our two intersections happens here. That's where the green graph intersects with the black graph, and also here. So how many points, how many orange points are there? It's 2. So that is the number of solution when those two graphs are intersecting. So your answer for this is just going to be 2 solutions. So it's going to be just 2 solutions because there are 2 orange points that I've just put in. So it's going to be 2 solutions. So that's how you would answer this question. So now we're going to do 6.3, and it says for which values of k will g of x minus k equals to 1 have no roots, right? So now we need to understand no roots. Remember the fact that in nature of roots, no roots means what? So in nature of roots, so in nature of roots, comma, no roots means that the triangle, right, is what? Is less than 0. That's what it means. But this only works, so this only works, so this only works for quadratic function, right? So this only works for quadratic function. So with that said, right now, let's translate the nature of roots. Let's translate. So the first part that we need to do is that translate the nature of root to trigonometry, right? So now translating the nature of root for trig, right? So for trig functions, right? For trig functions. Okay, cool. Specifically, trig functions, we're talking about sine and cos, right? So this is for sine and cos. So trig functions, we mean that sine theta and cos theta. That's the only two that we're going to be talking about, right? So now what we're going to look at, we're going to look at when the nature of root is what? The nature of root, which was, we're going to look when there is real roots. So number one, for real roots, so for real roots, right? Then for real roots, we're looking for what? We're looking for the following. We're looking for when C, and I'm going to talk about C, what C is, right? C is in between -1 and 1, right? Equals 2. So it's between greater than and equals to of -1 and 1, right? So now for no real roots, so for no real roots, then for no real root is that C is going to be what? Less than 1. Or it's going to be what? It's going to be C is, what you call it, C is greater than 1 and C is less than -1. So this is for no real root. So what is C? So C is basically, to find C, it's going to be where? So C is going to be basically, if you're dealing with sine, it's going to be sine x or sine theta. So let's say sine theta is equals to C. So basically we're isolating whatever it is that when solving is that we're going to equate it by 0, right? And we're going to make sure the fact that the trig ratio is alone. That's what we're looking for. Or you know the fact that it can be cos theta is equals to what? Is equals to C, right? So we isolating the trig ratio. Hope I'm making sense. Then that is going to give us our C. This is going to make sense when I'm actually solving it, right? So now let's put this in a block, right? Then we're going to solve for C. So number one, solving for C. So number one is solving for C, right? So we see the fact that our question is saying what? It's saying g of x. So we see the fact that our question is saying g of x, right? G of x minus k, so it's minus k, is equals to what? It's equals to 1, right? So we need to find g of x. So we know that g of x is equals to what? It's equals to, let's go up. Our g of x is equals to sine x minus 60. So it's going to be sine x minus 60. So this is the same as sine x plus 60 is minus k is equals to 1. So our goal is to have this trig ratio. We don't care about what's inside. We care about this one being alone. So there shouldn't be a number in front of it. We want it alone. So this is the same as finding sine x plus 60 is equals to 1 plus k, right? So therefore our C is equals to 1 plus k, right? And we're looking for where there is no real roots. So for no real roots, we know the fact that it's C is what? C is greater than 1. So C is greater than 1, or C is less than -1. So we know that C is 1 plus k is greater than 1, right? So this is going to be the same as k is greater than 1 minus 1, right? Which is k is greater than 0. Or it's going to be what? It's going to be 1 plus k, right? Is less than -1. So it's going to be k is less than what? -1 minus 1, which is k is less than -2. So this is our final answer. This 2 is going to be our final answer. Hope that makes sense on how to solve this question. So now we're going to do 6.4. It says the graph h of x is obtained by reflecting g of x on the line x is equals to -30. Write down the new equation of h in the simplest form. So now let's understand what's happening, right? If we're reflecting, and this I'm going to put it in a block, it's a formula, right? So let me just zoom it in. If you are reflecting. So if you are reflecting any function, so any function, so in this case we're going to call it g of x, right? We're going to call it g of x, but it could be f of x across, okay, across a vertical line. So a vertical line x is equals to c, and I'm just going to make it c as being constant. In our case, our x is equals to what? Is equals to negative 30, right? Then the new function, so the new function, right? So the new function, which is in our case is h of x, is equals to, so it's equals to, so basically h of x, and you're going to always use this formula, which is going to be g, then this is going to be 2c, right, minus x. So this is the formula that you're going to use, right? So that is the formula that you're going to use, meaning now we're going to first find this, simplify this from our g of x, then substitute it back to g of x to find our new h of x. Hope that makes sense. So now having that idea logged in, right, is that we're going to solve for h of x, right? So we know the following. We know the fact that we need to look for 2c minus x, right? So we know the fact that 2c minus x is basically equals to what? Okay, cool. We can just solve it from inside. So let's solve for h of x. So it's going to be h of x is equals to g, then it's going to be 2c minus x, right? But we know that c is equals to what? Is equals to negative 30, right? It's from here. Remember? It's from this, right? So let's substitute. So we're looking for what? We're looking for g of 2, then this is going to be negative 30, right? Minus what? Minus x, right? And that's going to be close that. So this is going to be the same as g of 60 minus x, right? So now we're going to find g of x. We know that g of x is equals to sine, and that was what? Let's go up. Just want to confirm. Okay. It's x plus 60. So we know that g of x is x plus 60. So it's going to be x plus 60. So now what's going to happen is that now wherever we see x, we're going to substitute this. So I'm going to highlight what we're going to do. Wherever we see x, which is this, we're going to substitute by that, right? Because that's how our h of x is going to be looking like. So if we say a sine, so our x is going to be replaced by what? By negative 60 minus x, right? And this is going to be plus 60, right? So now let's clean this up. So it's going to be sine, then it's going to be minus 60 minus x, then plus 60. We see the 60 and the negative 6 are going to cancel out. So you're going to have negative sine x, which this is going to be the same as what? Negative sine x. So that is going to be what our h of x is going to be equals to. So now we're going to do question 7. It says in the diagram CD, right, is the vertical pillar, then ABC are points on the horizontal plane. So our point A, B, C are the points on the horizontal plane. Then they tell us the fact that AD, right, AD and DB are a straight, or what you call this, straight cable such that CD is equals to 15 meters, DB is equals to 20 meters, and they give us the angle. And everything that they tell us here, it's basically in the diagram, right? So now let's look at what they want us to calculate for the first one. The first one, they tell us the fact that we need to find AB. So AB is this, right? So there's three formulas. Yes, three formulas that we need to take into account for is the theorem of Pythagoras, or no, four things. Is you can use trig ratios if we have a right angle triangle, theorem of Pythagoras, right? if we have a right angle triangle. And also we have the sine rule and the cos rule, right? Depending on what we have, we can know where to use whatever that we need. So first, let's understand what we're looking for. We see the fact that it's here, which is on this triangle. You see? So we see the fact that it's on this triangle, right? So what information do we have? We have this and we have this only, right? So with that said, is that if we had to use our sine rule, right? If we had to use our sine rule, is that this situation needs to happen, is that this obviously it links exactly to what we want. So this angle links to the side that we want, right? Then we need an angle and a side. So meaning another side that we have that has values, right, could be this one. So let me just do it like this one, because it already has the 20 meters, right? So our goal will be, if we're using the sine rule, to find this angle, right? So looking at it is that looking at this triangle, this angle, do you see this angle here, right? Is that how can we get that? We see the fact that it's hard. We do not have enough information. If this maybe was a right angle triangle, probably. So it looks like the sine rule is failing, right? So another condition is using the cos rule. So the cos rule is that it's that the opposite side that we want. So it's going to be the opposite side. So which is going to be this one, right? So since we're looking for this one, right, is that we need its angle. So we need this side and this angle. Then we need the sides that are included on the angle. So we need this. So we see the fact that we have this side. The only side that's missing is this side. And we see the fact that we have enough information to find that side using this right angle triangle. Do you see? This is a right angle triangle, right? So using the right angle triangle, we can use trig ratio because we have one side and we have an angle. So using this as a reference, we know the fact that this is going to be adjacent, right? So this is going to be what? This is going to be our, this is actually our hypotenuse, because see, so this is going to be our hypotenuse, right? And this is going to be our adjacent. So the one that is opposite the 90 is the hypotenuse. So we're looking for the hypotenuse. So we see the fact that the common side that we're looking for is AD. I'm going to use the yellow triangle to find AD because it's the right angle triangle. So now let's solve this, right? So first it's finding AD, right? So finding DA. So we know the fact that in triangle DCA, right, we have the following. We know the fact that we can find, remember the fact that that is cos, so it's going to be cos of the angle, let's name that angle, which is going to be CDA, right, is equals to what? It's going to be equals to, meaning this angle here is hypotenuse, so hypotenuse is going to be what? Our hypotenuse is going to be DA, so it's going to be adjacent, which is our adjacent, sorry. Our adjacent is this one, which is going to be DC over hypotenuse, which is DA. Hope that makes sense, right? So now having that, we're going to substitute the actual values for each and every one of them. So substituting the values, we're going to have the following. We know the fact that this is the same as cos 28 degrees is equals to 15 meters, right? And this is going to be divided by DA, which is what we want. So cross multiply, so it's going to be DA multiplied by cos 28 is equals to 15. So this is the same as DA is equals to 15 divided by cos 28, right? So punch that into the calculator. You're going to find that DA is equals to what? Is equals to 16,99 meters, right? So we found the common side, which is DA, right? So now using cos rule, so using cos rule to find what? To find AB. So now, if I'm going to write it back into this triangle, this is going to be what? This is going to be 16,99, right? Meters. So now using cos rule, we know the fact that cos rule is what? Is going to be the side that we want, which is going to be AB. So it's going to be the side, okay, so it's going to be the side that you want, right? All squared, right, is equals to the side that is in the included, the side that are included on the angle. So it's going to be this side, right, multiplied by this side squared, right, plus this side squared, right, minus 2 this side multiplied by this side cos of this angle. Hope that makes sense. So it's going to be AB squared, what we want, right, is equals to is equals to dA. So it's equals to dA squared, right? Then the other side is dB plus dB squared minus these two sides again. So minus 2 of dA multiplied by dB, right, multiplied by sine of the included angle, the angle that's between those two sides, which is this angle, which is ADB. So ADB, so sine ADB. ADB. Hope that makes sense, right? So now let's fill it in. We know the fact that we're looking for AB squared is equals to dA, right, is going to be 16,99 all squared, plus, remember the fact that we were given dB, which is 20. So this is going to be 20 all squared minus 2. Then this is going to be 16,99. Then it's going to be 20. Then it's going to be sine. And what is that angle? That angle is 52. So it's going to be 52. Punch that whole thing into the, punch this whole thing into your calculator. You find that AB, right, AB squared is equals to what? It's equals to 270, comma 256, right? Then now we're looking for AB, right, meaning square root both sides. So it's going to be the square root of 270, comma 2, so 256, right? So when you punch that into the calculator, it's going to be equals to 16,44 meters. So now we're going to do 7.2. It says if J is the point, so if J is the point, which is J is here, right, is the point on the line on the side HL, so on this line, as we can see, right, such that this and this are equal, so those two sides are equal to each other and they both equals to K, right? And they tell us the fact that the angle of H is A and the angle that is HG J is equals to B, right? Then they tell us the following is that what is the area? So they want us the area of GLL, GJL. So let's highlight it in red, right? So they want the area of GJL. So this triangle, right? And very important, we see the fact that they want the area of that, right? So that is sorted. So before even determining how we're going to solve it, our goal is to fill in this triangle with as much information that we can have, right? So we see the fact that we can find J1, right? So first finding J1, and I'm just going to do it here. Find J1, so find J1, right? In terms of find J1. Let's not even write in terms. Find J1. We see the fact that from this triangle, right, is that we have A, we have B, so we can find J1 in terms of A and B, right? So we know the fact that the sum of angles in a triangle is going to be angle H. So we know the fact that H plus the angle which is HGJ, right, plus J1 is equals to 180 degrees, right? That is sum of angles in a triangle. We know that, right? So we know the fact that H is going to be what? It's going to be A plus, this one is going to be B plus J1. It's going to be equals to 180 degrees. So this is the same as J1 is equals to 180, right, minus A minus B. Take out the negative as a common, so it's going to be J1 is equals to 180 minus A plus B, because anything that was negative becomes positive and everything that was positive becomes negative. Hope that makes sense. So we know that J1 now is basically equals to 180, right, minus A plus B. Hope that makes sense, right? So we can also find J2. So find J2, right? So we know that J2 is what? Is J1 plus J2 is equals to 180. That's angles in a straight line, right? So therefore, we know that J1 is already 180 minus A plus B, right? Plus J2, right, is equals to what? Is equals to 180. Take everything to one side. We know the fact that J2 is basically equals to 180 minus 180 plus A plus B, right? So J2 is basically equals to A plus B, right? So we see the fact that here J2 is going to be A plus B, right? So now we know that J1 and J2 is equals to that. Then from that is that, remember the fact that we're looking for area of this triangle. If we look at the solution, right, it has this sine A plus B, right? And we need A to be isolated and B to be isolated, right? So we see that, right? We see the fact that to find the area, since sine is this, meaning this is the reference angle that we need to use from this triangle, right? This is the reference angle that we need to use. So meaning the area of any triangle, right, using the sine rule, is the included angle and the sides, right? So we see the fact that we have one side, which is K, but we do not have this side. We do not have this side, right? So how do we solve for the missing side with this one? Is that we're going to use this triangle to basically solve for the common side, which is GL, right? Because do you see the fact that this side we have A, we have B, and we have C, right? So we can use what? We can use the sine rule, because if I do this from the side that we want, so if I do this, okay, cool, let me just go back. If I do this, right, I can find, okay, let me just maybe change the color. Because if I do this, right, is that I can find what? I can find the side GL, which is a common side. And also, right, if I do this, I'm going to find sine being, do you see the fact that I need sine A and sine B? So I know the fact that if I use the sine rule, right, I'm going to have sine A. And also, if I use sine rule, I'm going to have sine B. And K is there. So that's nice. So using sine rule, so solving, so finding GL, which is common, right? So finding GL using sine rule, using sine rule. So we know the fact that sine A, right? So sine A is equals to GL. So it's going to be GL. And we know that sine B is equals to K divided by K. Sorry, it's divided by K. Cross multiply. So this is going to be K multiplied by sine A. And it's going to be GL multiplied by sine B. So make GL the subject. So this is going to be K multiplied by sine A multiply. Sine A divided by sine B is going to be equals to GL. So we know that GL now is basically equals to that. So that's good, right? So now finding the area. Finding the area of triangle what? Triangle GJL, right? It's going to be equals to. So it's going to be the included side of that angle. So it's going to be GJ multiplied by JL and the sine of the included angle. So it's going to be that. So it's going to be GL multiplied by JL. So it's going to be JL. Then it's going to be sine of the included angle. And that included angle is GJL. GJL. So now let's substitute. We know the fact that GL is what? Is K sine A divided by sine B. Then GL, we know the fact that that's K, so that's going to be K, and this is going to be sine A plus B. So now let's clean it up, right? Multiply all the numerator, so it's going to be K squared sine A multiplied by sine A plus B, and this whole thing is divided by sine B. Then let's go up. Do you see the fact that this is exactly what they want? So that's how you would find the solution to this question. So now we're going to do Euclidean geometry. We're going to do question 8, right? So with question 8, the first thing that we need to do is fill in the diagram. So they tell us the fact that in the figure below, O is the center from the circle. So we see the fact that O is the center. So the first thing that you need to think about is all the properties that are related to the center. So the first one is angular center twice the angular circumference. We see the fact that we need 2 reference points, right? 2 reference points from the circumference that's connecting to the center and also connecting to the circumference. We see the fact that if we take point S and we take point Q, let's check, right? We're checking whether this can create angular center twice the angular circumference. We see the fact that point S can go to O, which is the center, and point Q can go to O2, which is center, right? Then we need to make sure the fact that point S, right? So we need to make sure that point S goes to the circumference. We see the fact that the only line that point S goes to, right, is point Q. Again, right? That is the point on the circumference. And we see the fact that point Q goes to point P. Do you see the fact that this doesn't create angular center twice the angular circumference? Because if it was the case, this should have went here and this should have went here. So we see the fact that this goes here and this one goes here. So angular center twice the angular circumference doesn't work there. Then we can try another 2 points, right, on the circumference, right, which is our 2 point can be this point and this point. We see this one goes to Q, but this one doesn't go to what you call, sorry, Q goes to O, but R doesn't go to O, it goes to P. It needs to go to O and also go to P if it's going to share that. Hope I'm making sense, right? So we see the fact that if I try all of them, and just let me show you, if I do this and this, do you see the fact that this doesn't work? And also even I take 2 of this as the reference point, this one goes to the center, but this doesn't go to the center. So angular circumference twice the angles of angular circumference twice the angle, twice the angle, angular center twice the angular circumference does not work. That's what I wanted to say. Then now, meaning we need to go to the next one, which is the radius. We see the fact that we have a point O here and it touches the circumference. This is a radius and this one is also a radius, right? So since this is a radius, we see the fact that in this triangle here, do you see in this triangle that I'm highlighting in red, it's going to create an isosceles triangle, meaning this, so let me just do this, sorry. Meaning this side and this side are equal. If that's the case, the meaning this angle is equals to this angle. And since if you're looking at this, is that this is in terms of 2x, we can write this 2 in terms of x. Hope I'm making sense. So now let's do that, right? So we know the fact that O is the center. So we know the fact that O is the center. O is center. So we know the following, right? We know if O is the center, we know the following. We know that QO is equals to what? Is equals to OS. And the reason is radius. Radii. Then, therefore, we know the fact that angle Q2 is equals to angle S1, right? And that is isosceles triangle, meaning it's opposite angles, opposite sides equal, right? Opposite angles equal, right? So now in that case we can solve what those what Q2 and Q1 is, right? So we know the fact that angle Q2 plus angle S1 plus angle O2 is equals to 180 degrees. And the reason for that is sum of angles in a triangle. So sum of angles in triangle. right? So now let's substitute. We know the fact that this, I can write it in terms of just Q2, both of them, maybe Q2 plus another Q2. And we know the fact that this is equals to 2x is equals to 180. So this is the same as 2Q2, right, is equals to 180 minus 2x, right? Then we know the fact that divide both sides by 2, so it's going to be angle Q2 is equals to 180 minus 2x divided by 2. And this is the same as Q2 is equals to 180 divided by 2 is 90. And this is going to be minus x. So we know the fact that this is going to be 90 minus x. So let me just do this. It's going to be 90 minus x. And also, this is going to be 90 minus x. Okay, so we have that, right? But remember the fact that we did it from this when we found angle at center twice the angle at circumference. But we have when angle at center twice the angle at circumference from outside. This is going to be our reference. So let me just do this and just show you with a different color. Maybe let's pick orange. And let's pick an orange highlight. We're still dealing with O being the center, right? This is going to be our 2 reference point, right? And this being our 2 reference point, we see the fact that both Q and S goes to the center, meaning this angle that's outside is going to be angle, angle at center twice the angle at circumference, and the angle at circumference is going to be R, because S goes to R and Q goes to R, meaning this angle is going to be angle at center twice the angle at circumference, right? So with that said, we see the fact that we have the following. First, we need to find this angle O1, right? O1 is going to be equals to what? Since it's angle on a revolution, this is going to be basically 360, right? Because angle O1 plus O2 is going to give you 360, but we already know what O2 is. So to find O1 is going to be 360 minus O2, which is going to be 2x, right? So we have that. Now we can find the angle R1 and R2. Hope that makes sense, right? So now let's do that. So we know the fact that angle at center twice the angle at circumference. We know the fact that angle O1 is equals to 2 times angle at circumference, which is angle R1 plus R2, right? That's angle at center twice the angle at circumference. So it's going to be angle at center, right, is angle at center, right, is equals to 2 times angle at circum. Hope that makes sense, right? So that's what we have, right? So now we can solve what O2 is, right? So O1 is, so we know the fact that angle O1 is equals to 360 minus 2x, right? And that is going to be angle on the revolution, right? Then we know the fact that we can solve R1 plus R2, right? So let's do that. So we know the fact that angle O1, right, is equals to 2 times angle R1, right, plus R2. So we know the fact that angle O1 is equals to 360, right, minus R2, which is, it's going to be 2R, sorry, which is going to be 2. Then this is going to be R1 plus angle R2, right? So divide both sides by 2, so it's going to be 360 minus 2x is divided by 2 is equals to R1 plus angle R2. So this is the same as 180 minus x is equals to R1 plus R2. So going back in the diagram, this is basically equals to 180 minus x. Moving into the diagram, right? If we already know what this angle is, which is 180 minus x, they gave us the fact that these two are equals to each other, meaning it's going to create an isosceles triangle. So let me just clean this up like this. So we know the fact that this is angle O1 plus O2, but we see the fact that, and I'm just going to do it in green, we see the fact that we're going to create, this creates an isosceles triangle, right? So we given the fact that these two are equal, meaning we have this angle. So do you see the fact that I can find angle S2, sorry, and angle Q1? We can find that, right? So let's do that. So let me just do that. So we know the following. We know the fact that, so let me just move this into my green. We given that, so we given that QR is equals to RS. So using that information, right, we know the fact that we can find what? We know the fact that if opposite sides are equal, then the angles are equal to each other. So meaning angle S1, so meaning angle S2 is equals to angle Q1. So those two angles are equals to each other, right? And we can solve what that angle is, and that's going to be opposite sides equal. So it's opposite sides equal, right? Opposite. So it's opposite sides equal, right? Meaning opposite angles equals 2, right? So we're using sum of angles in a triangle, we can solve what S1 and S2 is, S2 and Q1 is, right? So we know the fact that angle S2 plus angle Q1, right, plus angle R1 plus R2 is equals to 180 degrees. And that's going to be sum of angles in a triangle, sum of angles in triangle. So we know the fact that I can rewrite S1 and S2 as being one thing. So I'm going to rewrite everything as being S1. So this is going to be S2, plus another S2, because we know that Q1 and S1 is the same thing. So then this is going to be R1 plus R2 is equals to 180. We already solved that R1 plus R2 is 180 minus X. So this is going to be 2S2 plus this is going to be 180, right? 180 minus X. So it's going to be 180 minus X is equals to 180 degrees, right? So this is take everything to one side. So it's going to be 2S2 is equals to 180 minus 180 plus X. So this is going to be 2S2 is equals to what? Is equals to X, right? Therefore, S2 is basically equals to X divided by 2. So we see the fact that this 2 is going to be X divided by 2, and here is going to be X divided by 2. So now we basically have everything that's related to the center and extended it, obviously, is done. So we know the fact that the center part was this part. Then they continue and tell us the fact that P, Q, R, and S are points in the circumference. So we know that P, right, Q, right, R, and S are points in the circumference. If we have 4 points in the circumference, we need to think about like things that are related to cyclic quad, right? We see the fact that if I make point S and point point S and point P, the reference, I can connect point S to another point in the circumference, which is Q, and I can connect also another and connect that P value also to that same point, which is Q. Do you see that? Then also we see the fact that we can connect, P can also connect to R, and also S can connect to R, meaning it creates a butterfly. Meaning, what do we see? We see the fact that, you see the fact that this angle R1 is equals to this angle Q2 plus Q2 plus Q3. And we also see the fact that this angle S2 is equals to angle P, and that's angles in the same segment. So let me just write this. We know the fact that, so going to blue, right, we know the following. We know the fact that for the points, right, so the points that we have is PQR, so it's PQR, so it's PQR and S, right, and S and S. So we're dealing with points on the circumference, right? We see that angle R1, because it created a butterfly, angle R1, right? Angle R1 is equals to angle Q2 plus Q3, right? So it's equals to Q2 plus angle Q3. And that's angles in the same segment, right? Then we see also that angle S2 at the bottom of the butterfly, S2 is equals to what? To angle P. So it's equals to angle P, and also that's the same angles in the same segment, right? So we see the fact that since this we solved it as x divided by 2, so this is also x divided by 2, right? So now we see the fact that if we look at our diagram, it's more or less complete. Our diagram is more or less complete. We do not have anything else to add. So now we can go basically and answer the questions. So now we're going to start answering the questions. So the first one says, express the following in terms of x, right? And give the reason to your statement. So we need to express everything in terms of x and give reason to our statement. So now let's start with 8.1.1, right? So they want us to find QRS. So I'm going to zoom it out and see where QR is. So Q is here, RS is here. So do you see the fact that they're looking for this angle, which we solved as being 180 minus x? So they want this angle, which is this. And when we go back to our orange, right, we see the fact that that is here, right? So this whole thing is basically our solution. This whole thing, right, is basically our solution. So our solution is here, right? So our solution is here. So now let's see how we got there to being this. First is that we found that this is equals to what? To this, right? And we wrote it already in here, right? We wrote it in here. Then after that is that we went and basically connected here. Then this was given, and this basically solved this one. Hope that makes sense. So we started here, then it made this. I think I just added extra things. So now we know the following. We know the fact that, so now let's basically answer this question. We're going to start with it being a revolution, right? So it's going to be points around the, what you call this, angles around the point. So we know the fact that, let me just erase this. So we know the fact that first angle O1, right? So angle O1 is equals to 360 minus 2x, right? And our reason is going to be, I'm going to write the proper reasons, angles around a point, they add up to 360, right? So now we have that. Then we see the fact that the angle that they want is going to be angle O1, right? Is equals to 2 times the angle they want, which is QRS. And the reason for that is going to be what? Angle at center twice the angle at circumference, angle at center, right, is equals to 2 times angle at circumference, Hope that makes sense, right? So now we can solve for QRS. We know the fact that this is 360 minus 2x, right, which is going to be equals to 2QRS. So therefore, we know the fact that QRS is basically equals to, put the cap on the wrong one here, right? We already solved it here. We know the fact that is equals to 180 minus x. So this is going to be equals to 180 minus x. And you're done solving this question. So now we're going to solve for Q1. Let's go back to the diagram. Q1 is this one. And we solved it as x divided by 2, right? And we use the fact that we know this and this are already given as being equal, and opposite sides equals, meaning the fact that opposite angles are equal, and we already have this. Hope that makes sense, right? So first, we know the following. We know the fact that angle, and this is from here. Do you see here? We already solved it. Remember the fact that angle Q1 and S2 is the same thing. So we already solved it. So we know the fact that these two angles are equal because of opposite sides angles are equal. Then we found sum of angles in the triangle. So what I'm going to do is that I'm going to write this statement, right? Then I'm gonna basically write this one, right, just to put this. Then therefore I'm gonna conclude that Q1 is equals to x divided by 2. Hope that makes sense, right? So that's how we're going to solve this question. So we're gonna start with what? We're going to start with knowing the fact that opposite sides equal, right? Opposite angle, what you call this, opposite sides equal means opposite angles equal, right? So we know the fact that angle Q1 is equals to angle S2, right? And our reason is going to be what? Angles opposite equal sides. Hope that makes sense, right? Then we know the following. We know the fact that angle Q1 plus angle S2 plus this angle here, which is ORS, right, is equals to 180 degrees. And the reason is sum of angles in the triangle. So it's going to be sum of angles of a triangle, right? Then therefore we know the fact that angle Q1 is equals to what? Is equals to x divided by 2, right? That's how you would answer this question. So now we're going to do question 8.1.3. It says it's one angle P. So let's go back. We see that angle P is equals to this one, which is x divided by 2. And the reason is angle in the same segment. So we know the fact that angle S2 is equals to angle angle P, which is going to be x divided by 2. So let's just do that. So we're going to first state the fact that angle S2 is equals to what? Is equals to angle P, right? And the reason for that is going to be angles in the same segment, which is going to be sec. Therefore, we see the fact that angle P is also equals to what? To x divided by 2. Hope that makes sense. So that's how you would answer this question. So now we're going to do 8.2. It says in the diagram triangle A, so triangle A, C, E, right? And on C, and has a point D. So they tell us the fact that it has a point D on this line, which is CE. And it also has a point F on the line, and also has a point F and a point point H on the line AC, which is this line, such that then they tell us the parallel lines that DF is parallel to EF. So DF, which is going to be this line, so DF is parallel to this line. So the minute you see parallel lines, right, is that try to draw a triangle around it. So let's draw a triangle. So we see the fact that we have these two lines parallel. So I'm going to have this two lines parallel. Then I'm going to try to form a triangle around it, right? So I see the fact that I can form this triangle. Reason why is proportionality theorem is going to play a role here, right? So I see that. Then they tell us the fact that D is produced at G and AGB, such as GH and BC is drawn. And they tell us another set of two parallel lines. We see another two sets of parallel lines, which is this line, GH is parallel to BC, which is this one. We see the fact that we can form a triangle also there. So meaning proportionality theorem is going to play a role in that triangle. So we have two triangle, which is the yellow one and the blue one that plays proportionality theorems, right? Then they continue and give us more information. So the more information that they gave us, they tell us the fact that BE ratio, is the ratio to CE, right? So meaning BE, meaning BE is, okay, wait. I'm going to erase this. Okay, cool. They tell us BE, right, is to this. So meaning this 2 matches up with this side and this 5 matches up with this. Since this is in ratio form, right, is that this is the same as 2x and this is the same as 5x, right? Because it's not the actual unit, it's the ratio. Hope that makes sense, right? So now let's look for DE. So DE, we know the fact that it's going to be this one, which is going to be 2. And they tell us the fact that they tell us the fact that DE is going to be what? DE is this one, and CE is from this point till this point, and that is equals to 5, right? So this is x, so this is x, and this is 5x. So since we have a total of that side and we have one side, if I say to find this one, is going to be the total minus this, which when I say 5 minus 2 is going to give me 3. So this one is going to be 3x. Hope that makes sense. Because when I say 3x plus 2x is going to give me 5x. Hope that makes sense, right? So we have filled in that part. And finally, they tell us the fact that dg, which is going to be this portion here, is equals to 12 units. So we don't need to put 12x because it's in units. So this is going to be just 12, right? And looking at the diagram, that is that. So now we're going to answer the question that they want, right? So now we're going to do the first question. So it says calculate the length AG. So is AG is going to be this one. So I'm going to highlight it in red. So that is the length that they want, right? So now looking at the diagram in reference what they want, right? We see the fact that AG is in the ratio of this triangle. Do you see? It's in the ratio of this triangle. So this part is going to play a role with the blue triangle. But we see the fact that the only information that we have on the blue triangle is this one. But we see the fact that this yellow triangle, right, can give me the other side of the blue triangle because of the yellow triangle and the blue triangle share this side. Hope that makes sense, right? So what do we see? We see the fact that if I find the ratio of this side divided by this side, I'm going to get this one, right? And also I'm going to get the whole of this one. But what do we see? We see the fact that those two sides are equal. So whatever that I get this side is going to be equals to this portion here, right? And then I can solve for this. So to solve for this, we're going to start with the yellow triangle, right? Finding the ratio of the sides here. Then we're going to use the blue triangle to find AG. Hope that it makes sense, right? So yellow triangle, I'm going to reference this. So we're going to say yellow triangle. So stating. So it's starting with the yellow triangle, right? So the first thing that we know the fact that this side, right? So remember the fact that the sides that we want there, this one shares with this one, right? So we know the fact that using the yellow triangle is that we can solve this whole three parts, this whole side. That's what I'm trying to solve, right? So to do that, we see the fact that this, because we given, divided by this, right, is going to be equals to this one matches up with this side, right? And this one matches up with this one. So that's what we're going to do. So we're going to say that DE divided by DC is equals to what? To AF divided by what? Divided by FC, right? And the reason is going to be proportional theorem. Put the parallel lines. So the parallel lines is DF is parallel to EA, right? So now let's substitute. We know the fact that DE is 2x, so it's going to be 2x divided by 3x, which is going to be AF, right, divided by FC. So therefore, we see that AF, which is from this side, right? We see that AF divided by what? By FC is equals to 2 over 3. So now let's fill it in. So we see that AF, and I'm going to do it in red. We see that AF is this one is equals to 2, right? So we see the fact that this is equals to 2x. Then we also see the fact that this and this are equal, meaning from here to here. So this portion is also equals to 2x. But we also see the fact that FE, so it's going to be this whole portion. So what you call this FC is going to be this line and this line, right? So it's going to be this whole thing, right? is equals to 3, right? 3x. So we know the fact that this whole thing is equals to 3x. So do you see the fact that now we have this portion missing, but we already know what this portion is. So to find this is going to be what? It's going to be 3x minus this to find this, which is going to be 1. So this small portion is going to be equals to 1x, right? So it's equals to 1x, because when we say 3x plus 2x is going to give us 3x. So do you see the fact that now we have this whole side complete, right? We have that whole side completed. So now we can use the blue triangle to solve this one. Hope that makes sense. So now let's do that. So now using the blue triangle. So using the blue triangle, we see the fact that the side that we want, AG, so it's going to be AG divided by the side that they gave us, which is BG, divided by BG, is equals to, AG matches up with what on the blue triangle? AG matches up with A, what you call this, what you call this, AH, right? AH divided by what? Divided by, BG matches up with the small portion, which is HC. So it's going to be HC, right? And the reason is going to be proportion theorem. But remember that the parallel lines are different here. It's what is GH is parallel to what? It's parallel to BC. Hope that makes sense, right? So now let's substitute. AG is what we want. Then BG is equals to 12. So it's going to be 12 here is equals to. Then AH is this side. Do you see the fact that AH is this portion, which is 2x plus another 2x, meaning it's 4x. So it's going to be 4x divided by HC. HC is this small portion, which is going to be 1x. So it's going to be just x, right? So the x's are going to cancel out. So it's going to be AG divided by 12 is equals to what? To 4, right? So now we're looking for AJ. So cross multiply. So it's going to be AJ is equals to 4 multiplied by 12. So when you say 4 multiplied by 12, AJ is equals to 48 units. So that's how you would solve this question. So now we're going to do question 9, right? It says in the diagram O is the center. So we're going to highlight that part. We see the fact that O is the center that passes through F, S, H, and G, right? So we see the fact that O is the center. We see the fact that angular center twice the angular circumference doesn't play here. We see also that angles in the diameter. This is not a diameter. Do you see from here to here? Right, to create this is not 90. It looks like it. This can be 90, right, because this is not by the circumference. If R was here, then it was going to be that. So that there also doesn't play a role, right? The only one that plays a role is the what you call this theorem 1, which angle from, or what you call this, a line from center that cuts the chord creates 90 degrees. So meaning these two angles are equals to 90 degrees, and that is theorem 1. Hope that makes sense. That is the only, okay, two of them, right? Is that one, and also this one, which is radius. We know the fact that OH and OG are radius, so this creates a triangle, meaning this angle and this angle are equals to each other, because opposite sides equals, meaning opposite angles equal. Hope that makes sense, right? So now let's write everything that is reference to that. So let's make it in red. So we know the fact that O is the center, so center O. So we know the fact that we have center O. So having center O, as I said, the fact that the first one is going to be what? Theorem, what you call this is going to be theorem 1, right? So we know the fact that angle, so let me just, okay, let's start with the radius. So we know the fact that OH, so OH is equals to OG, and our reason is radii. So from that, we know that angle H, so it's going to be angle OHG is equals to OGH. And that is going to be what? What you call this? Opposite sides equal, opposite angles equal, right? So we have that. So we have sorted out that one. So now let's mark it in a different color. So we know the fact that this is going to be red. So this and this are going to be equals to each other. So let me just clean this up. So let me just do this. We know the fact that this and this are going to be equals to each other. Hope that makes sense. So the second one is going to be what? It's going to be theorem 1, right? So we know the fact that this angle here, so I'm going to just make it in a different color. We know that this angle here is going to be equals to this angle here, right? And that's going to create 90 degrees. So we know the fact that, what you call this? Okay, so we know that we know the fact that OH is going to be perpendicular to what? To SG. And we're just going to say theorem 1. I'm just going to say theorem 1. When writing solution, I'm going to write the proper theorem. So I'm going to just say theorem 1. Right? So that's what we have so far. So we have that, right? So now we're going to move on into the second part of the question. So I'm going to make it into maybe blue. Maybe this dark blue. And I'm going to match the highlighter in blue. They tell me that DG, DF, and DS are tangent. So they tell me that two lines are tangent. So this line here and this line here are tangent. What do we see? We see the fact that it's two tangent lines going to the same point, meaning this side and this side are equal. Meaning what? Meaning this and this are equal to, right? So what do we see? We see the fact that this and this are equal, right? Because of its tangent at the same point. So what do we see that? So we're going to say tangent then we know the following. We know that F DF. So we know that DF is equals to DS. Tangent same point. I'm going to say tangent same point. All right. Then what do we know? We know the fact that now angle F1 is also equals to angle S1. Right. And our reason is going to be opposite side equal means opposite angle equal. Hope that makes sense, right? So we know that. So in tangent line, we see the fact that we can't make 10 chord because you see the fact that if it's a tangent, so it's going to be this line, then it's going to be a triangle that touches the circumference. We see the fact that F is at the circumference, then H is at the circumference, but there is no line connecting these two. And also from here is that creating a triangle, it needs to touch the circumference. We see the fact that that doesn't also happen. Only this here, but there isn't a line connecting these two. Hope that makes sense, right? So the only properties that we have here is the tangent connecting at the same point. Let me just delete this, which is gonna be the only thing that we have here, right? So we have that. Then now we're gonna move to, maybe let me just make it in orange, my highlight in orange. Now we're gonna move to, so let me just do this, go back to blue for a moment. Let me erase this and make this 2. Yes. Then now we're going to move to the next part of the statement. So it says to the circle S and P respectively. They tell me that SG is parallel to DF, right? So SG is parallel to DF. So orange. So they tell me that this line is parallel to this line. And we see the fact that we can form a Z here, right? So meaning this and this are equals to each other, right? So we see the fact that that two are equals to each other. So we see the fact that since this is already blue, so meaning this one is also going to be in blue. So this one is also going to be blue, right? So we see the fact that that is going to be blue. So alternative angles. So we see this two are equals to each other and it's going to be blue. So we see the fact that what parallel lines, so we have parallel lines. It's going to be parallel lines. Parallel lines is in orange, so I'm going to do this. So it's going to be parallel lines. Parallel lines. But the statement is going to be in blue because of it matches with this one. So we see the fact that angle F1. So we see the fact that angle F1 is equals to angle S2, and that is Z. Right? And looking at the parallel lines, we see the fact that that's the only property that matters, right? So we see the fact that that's the only property that matters, and that is going to be for parallel lines, this point. Right, so at this point, let me just go back. It's going to be this one. Then they tell us the fact that DOH intersects with GE at T, and OG is drawn. So they're talking about the diagram. That part doesn't matter, honestly, because the diameter doesn't do anything to us. But there's one point, right? There's one part that is, I see the fact that we have, right? You always need to check, do we have 4 points on the circumference? We see the fact that F is on the circumference, S is on the circumference, H is on the circumference, and G is on the circumference. We see the fact that if we take what? If we take this two as the points on the circumference, this point can connect to F. So basically this point here, okay, so if you take this 2 points here, you see the fact that F can connect to S, and also G can connect to S, which is good, right? Can F connect to H? Let's see. And also we see that G connects to, connects to H, all right? So meaning these two are going to be equals to each other. So these two are going to be equals to each other, and these two are going to be equals to each other. So now let's update it. We know the fact that this is what? This is blue. So meaning this point here, where is it? Blue. Okay, go. Yes, it's here. So you see the fact that this red one is now updated to being blue, right? Meaning this one is also blue now, right? So we also see the fact that, yes, we see the fact that that is blue also, right? Then we see the fact that this green, only this small one, is equals to this one as being green. Hope that makes sense, right? So now let me clear this up so that we can update it properly and you guys can see what I mean. Because of angles in the same segment, we have this, the fact that this green one, right, is equals to what? Is equals to this green here. Hope that makes sense. Then blue is going to be where? Blue is going to be this one here. Do you see the fact that this blue and this one, and also this one is going to be also blue, right? Because of it's an isosceles. Remember, if this is blue, then it affects this blue one. Hope I'm making sense, right? So now let me just update it. So this is going to be small green. So let me just do this green. Yeah, because it is, yes. So now let's write it, right? So we have the following. We have points on the circumference, so it's point on circum. Always check whether you have 4 points and does it form a butterfly, right? So we see that angle S, so I'm going to make it in blue. We see the fact that angle S2 is equals to angle H, right? Angle S2 is equals to angle H, and that is going to be angles in same sec, right? So, and let me go up. This is also blue, meaning the fact that these two angles are also going to be equals to blue. I'm going to put a star there, they also equals to blue, right? So now if that's the case, then we have that this one is going to be in green, that angle F2 is equals to angle G2. And that's going to be the same reason as this. Hope that makes sense, right? So now if you look at it, the diagram is more or less complete, right? So we can go and answer the questions. So now let's answer the first question. It says we need to prove that two triangles are similar. So let's highlight the first triangle, which is D, right? So it's DS, so it's come here, DSF. So it's going to be this triangle, meaning this big triangle, right, is similar to O. So O is this one, OG. So it's going to be this triangle, right? So we need to prove this. So we see the fact that both triangles have blue, and it's two of them, and blue is two of them, right? So now we need to prove the fact that those two triangles are similar. And by just looking at it, they are all of them are equals to each other, which is great. And this one, since it's the remaining one that is not, we can say the fact the sum of angles in a triangle. So solving similarity, the nice thing is that you just need to prove that two angles are equal. Then the other one, you can just say sum of angles in a triangle, right? So now let's start, right? So we're going to say in triangle. So we're going to start, we're going to say in triangle D. Black. So you're going to say in triangle. So in triangle DSF and O and triangle OGH, right? So the first statement, I'm going to match it up. Remember the fact that this and this are equals to each other, right? And we know that this and this, to get this, basically to get this and this to be equals to each other, the connecting point is this one, and this being equals to a together is sum of angles in a triangle. So now we're going to start. We know the fact that angle F1, right, is equals to angle S2, and the reason is going to be what? It's going to be alternating angles, right? It's going to be alternating angles. And we know the fact that always make it a habit of putting parallel lines. We know that DF is parallel to SG. Hope that makes sense, right? So we know that, right? Now we need to connect S2 to angle H. So we know the fact that angle S2 is equals to angle H, right? And maybe let's just name it the way it is, or let's just leave it as H, right? And the reason is going to be angles in the same segment. So it's going to be angles in the same segment, right? So therefore we know that angle F1 is equals to angle H, which is good, right? So now we have our first angle being equals to each other. But remember the fact that we know the fact that F1 and S2 are equals to each other, right? And also we know the fact that these two are equals to each other, and also these two are equals to each other. Therefore, meaning these two are going to be equals to each other, because all four of them are equals to each other. Hope I'm making sense, right? So now let's connect this. So basically we want to connect these two as being equals to each other, but we need to start by explaining this, right? So we know the fact that the second statement is that we know that angle, first we need to say how those two, meaning the sides, are equal. So we're going to say DF is equals to DS. And the reason for that is tangent. So it's going to be tangents from the same point, same point, right? So now we know the fact that angle F1 is equals to angle S1, right? And the reason for that is opposite. It's going to be opposite angles. So it's going to be opposite angles. So it's going to be angles opposite. So it's going to be angles opposite, right? Angles opposite equal sides. So we know that, right? So now if those two are equals to each other, now we need to go back to proving that these two are equal. So with this two, we know the following. We know the fact that so we know the fact that OH is equals to OG. And the reason is radius. And therefore, we know the fact that angle H is equals to angle OGH. And that's going to be angles opposite, equal sides. Equal sides. Right? So now we know the fact that therefore, since all of them, they're equals to blue, we can conclude that angle S. So therefore, we can conclude that angle S1 is equals to OGH. Right? So with that said, therefore, the final angle, so now the final statement, which is statement number 3, is that we know the fact that here angle D is equals to angle O1. And that's going to be sum of angles in the triangle. So sum of angles in triangle. Therefore, we can conclude that these two triangles are similar. So therefore, we can say triangle DSF is similar to triangle OGH. And our reason is all the statements are angles. So it's going to be angle, angle, angle. And that's how you would prove this question or solve this question. So now we're going to do 9.2. It says it is further given that OG is equals to 7.5. So OG is equals to 7.5. Right? And they tell us the fact that RH is equals to 1.5. Then they want us to calculate the length of SG. So the length of SG, so it's this length. Right? So what do we see? If we zoom in, right, and I'm just going to do it with a different color. If we zoom in, is that since we know the fact that this is a 90 degrees, do you see the fact that this triangle is going to create 90 degrees, right? And we know the fact that OG is a radius, and we know the fact that OH is a radius. And they gave us a small portion. So I can find what is OR, which is going to be this total, which is the radius. So we know the fact that OH is 7.5 minus this portion, I can get this, right? So let's start there. We know the fact that since it's a radius, that is going to be the case, right? So we can find this, which is going to be equals to 6. And I'm going to show you on how to do it, right? So this portion here is going to be 6, right? So since we see the fact that we have this whole triangle complete, we have this, we can find this using a theorem of Pythagoras. But do you see the fact that the whole of SG is made out of these two parts and they both equals to each other? If I find this and multiply by 2, I get this whole section, right? And how do we know the fact that this is why this is equals to each other? Is because of theorem 1, right? This creates 90 degrees and therefore these two sides are equal. So that's what we're going to do. So the first thing that we're going to do is that we're going to basically say how we got this to be 6 and use theorem, and then we're going to define how we got this to be 90, right? Then use theorem of Pythagoras to find this section. Then from there, we know the fact that since these two are equals to each other, this is going to be this twice. Hope that makes sense, right? So now let's start by doing what? Preparing everything, how we got OR to being what? To being equals to 6. So let's do that, right? So let me just do that. So we know the fact that we know the following. We know that OG is equals to OH. And that is going to be radii. Right? So it's going to be equals to radii. But we know the fact that OH, right, is equals to OR plus RH. Right? So we know that OH is equals to what? Is equals to 7,5, because that's the radii, the thing that they gave us. Then OR plus RH, which is going to be 1,5. So we know the fact that 7,5 minus 1,5 is equals to OR. Right? So therefore, OR is equals to 6 units. So we know that, right? So we have filled in that triangle, the yellow triangle, that side. But to use theorem of Pythagoras, we kind of need to say how we got this to being 90 degrees. Hope that makes sense, right? So we know the fact that OR, so we know the fact that OR, right? So let's name the angle, right? So we know the following. We know the fact that first we know that ORG, right, is equals to angle SO. Okay, it's going to be OR. So we don't need to say that. So ORG, because I need the triangle, is equals to 90 degrees, right? And the reason why it's going to be line from center, line from center. This is theorem 1. Line from center is perpendicular to the chord, right? And also, this is going to be the reason why those two sides are equal, right? So we're going to rewrite this reason again. So we know the fact that that is 90. So we know the fact that this is 90. Now we can use the yellow triangle to solve this side, right? So I'm going to just say this using the yellow triangle for reference. It's going to be using the yellow triangle, using the yellow triangle, right? So using the yellow triangle, we know the fact that OG, which is the hypotenuse, OG squared, right, is equals to OR squared plus RG squared. And our reason here is going to be Pythagoras. So it's going to be Pythagoras, right? So now let's solve. So we know the fact that OG is 7.5. O squared, OR squared is going to be 6 squared. And we're looking for RG. So it's going to be RG squared, right? So take this to the other side. So it's going to be 7,5. All squared minus 6 squared is equals to RG squared, right? So this is going to give me what? This is the same as 20,25, right, is equals to RG squared. So square root both sides. So it's going to be the square root of 20,25 is equals to RG. So therefore, RG is equals to what? Is equals to 4,5 units, right? But remember the fact that we're not looking for RG. We're looking for the whole thing, right? So we know the following. Now we know the following. We know the fact that RG, so we know the fact that SG, so we know that SG, okay, cool. So we know the following. We know the fact that SG, what we're looking for, we know that SG is equals to what? Is equals to SR, right? Plus what? Plus RG. So it's going to be RG. But we know the fact that SR is equals to RG, right? That is going to be theorem 1. As I said, the fact that we're going to go back to this. So duplicate it, cut it. We know the fact that these are both equals to each other, right? So meaning SG is equals to 4,5 plus another 4,5, right? Which therefore SG is basically equals to 9 units. And that's how you would solve this question. So now we're going to do 10.2. It says in the diagram EBF is a tangent to the larger circle, right? So this is a tangent to the larger circle at B. So this line is a tangent line, right? And we see the fact that we have a point here at B. So what I'm going to do is that since the tangent line is on two sides, I'm going to just focus on this side, right? Then we see the fact that we can create a triangle, and that triangle connects on the circumference of the bigger circle. Meaning we see the fact that this angle and this angle are equal to each other, and that's 10 chord, right? 10 chord theorem. So we see the fact that tangent line so we see the fact that angle B4 is equals to angle D2, right? And that is 10 chord theorem. Then now we're going to do the tangent, but looking at the opposite side, right? So we know the fact that these two are equal. So let me just put them in pen. So these two are equal, right? Then now I'm going to just make it in orange. We know the fact that from the other side, this side, that we can create a triangle now, like this. So meaning this one and this one are equals to each other. So I'm going to make it in orange and I'm going to put it here. So we know the fact that angle B2 is equals to angle C, and that is going to be 10 chord theorem. So now we know that this one, this is equals to this. So normally, let me erase this. Yes. Right? So we have that. Then we see the fact that if we create a line here, let me just move here. If I create a line going like this here, this creates vertically opposite angles, right? Meaning this angle here is also red, which is going to be what? Which is going to be vertically opposite angle. So lines, I'm going to say lines. So I see the fact that angle B4, right, is equals to angle B1, vertically opposite angles. Vertically opposite angles. Right? So we know that. And also this one, this is equals to this one. So we know the fact that ABF, so ABF is equals to angle B2 plus angle B3. And that's vertically opposite angles. Hope that makes sense. So let me just clean this up, right? So we have that. Then now we're going to continue reading the question. So the question says, CED and ABC are straight lines with point E, and A is a smaller triangle. What do you call this? A is a smaller circle, right? What do you call this? A is on the smaller circle, right? So E and A are smaller. What do you call are on the smaller circle such that AEDF. So we see the fact that on the smaller triangle, right, we have a cyclic quad. This is the cyclic quad. So I'm going to highlight it. So let's make it in green. So this is a cyclic quad. We see the fact that we have exterior angles over cyclic quad, meaning this angle here, because it's green. Okay, cool. We see the fact that this angle here, which is B3, is going to be equals to what? It's going to be equals to this angle here, exterior opposite angles over cyclic quad. And we see that this angle here, BD2, is equals to this angle here, right? Which is what? Which is A, right? So we see the fact that we have the following. So we see the fact that cyclic quad, so points on 4 points. So I'm going to say 4 points. 4 points on smaller circle. Underline that. So the first thing, right, is that we see the fact that angle D2 is equals to angle A. And that's exterior angle over cyclic, exterior angles of cyclic quad. Then we see the fact that, so this one is in red. Maybe let me just highlight it in red. This one is going to be in red because it matches up with the red one. Then we see that angle E2, E1 plus angle E2, right, equals to what? Equals to angle B2, B3, sorry. and that's going to be exterior angles of cyclic quad. We see the fact that in terms of cyclic quad, that's the only thing that we have. And now we can go answer the question. So now let's answer the first question. It says we need to prove, so let me just go take my highlighter. We need to prove that AE, so AE and AB are equals to each other. So we see the fact that this forms a triangle, right? So if we're trying to prove that those two sides are equal, we need to first prove that the two angles are equal. And we see the fact that both angles here, both opposite angles are red, meaning we can prove that these two are equal. So how do we get to this two being both red? We see from the beginning is that this angle here, right, is equals to this angle here, which is vertically opposite angle, right? Then we know the fact that this angle here is equals to this angle, which is 10 chord. And we know that this angle here and this angle here are what you call this exterior angle of a cyclic quad. So what we need to do is that we need to basically match these two being equals to each other. So we know the fact that these two are equal. So we know the fact that angle B4 is equals to angle B1, right? And that's vertically opposite angles, right? So remember, we're trying to prove that angle A is equals to angle B1, right? So now we know the fact that angle, angle B4 is also equals to what? It's also equals to angle D2, right? And that is what? That is 10 chord theorem. 10 chord, so it's going to be 10 chord theorem. So what we proved, you proved that these two are equal. Then what I proved this and this are equal, right? So I proved that these two are equal. Remember the fact that we're trying to prove that these two are equal, right? So now we know the fact that angle D2 is equals to what? Is equals to angle A. And that exterior angles of a cyclic quad. Exterior angles of a cyclic quad. Right? So what do we see? And maybe I'm just going to put a highlighter, right? We see the fact that this, right, is in blue. We see the fact that this, right, needs to be equals to angle B1. So we see the fact that this, so we know the fact that now I'm going to circle it back, right? We see the fact that this, right, so we know the fact that this and this are equal, right? And we know that this and this is equals, and therefore this is equals to this. I hope I'm making sense, right? So since everything is equals to each other, right? So therefore we see the fact that okay, maybe let me just go to the diagram. We see the fact that D2, right, is equals to angle A, right? We also see the fact that D2 is equals to B4, which B4 is equals to A1, right? So therefore, these two are equal, right? So therefore, we see the fact that angle A is basically equals to what? To angle B4, right? So therefore, we can conclude that what? That AE is equals to to BE, right? And that is going to be opposite angles equal, right? So our reason is the fact that since we know the fact that those two angles are equal, so opposite angles equal. So the reason for that is that since we know that opposite angles equal, opposite angles opposite are equal, and therefore equal sides, right? Angles opposite equal sides, because of we know the fact that if these two are equal, then therefore the sides are equals to. Hope that makes sense, right? So now we're gonna do 10.2.2. It says the length we need to prove, right? So this is proof that the length of ED, EA, EC, in this order forms a geometric sequence, right? So first, let's mark off the sides that they want us to prove. So we need to prove that ED, so it's going to be this side, right? And we need to prove that EA, which is going to be from this side. Then we need to prove that EC, which is going to be this side, right, forms a geometric sequence. What does it mean to form a geometric sequence? Meaning we need to write it in like this. So what we need to prove, so we're proving the fact that geometric sequence is them writing them in a ratio. So we're proving that ED divided by EA, because they say in that order, right, is equals to EC, and question mark we don't know yet, right? So this is what we're trying to prove, right? This is forming a geometric sequence because of when we're finding ratios, right? Remember the fact that to find R, it's going to be T2 divided by T1 is equals to T3 divided by T, which was T4. So this is basically forming a ratio. Hope I'm making sense, right? So this is what it means to be in a geometric sequence, right? So this, maybe let me just say this. This is what it means. What it means to form a geometric sequence. So let me just maybe extend this. Yes, right? So that is some keynotes. This is what it means to form a geometric sequence. If we know now that we're forming this, is that looking at this, right, is that we need to do what? It's two ways to basically prove, to create a ratio. It's either we're using similar triangles or we're going to use parallel lines. The parallel lines that we could have used here could be this line if this was parallel to this one. But looking at it, right, is that we can't prove that this line is parallel to this one. And even though, let's say the fact that we did have parallel lines, this will be the base, and the base are not part of the ratio. Hope I'm making sense. So the next best thing is going to be proving similarity triangles, right? So we see the fact that we need this complete side, right? Meaning our first triangle needs to have this complete base. So from here to here needs to be our side, this side. EC needs to be part of our side, right? And then the next side, right, let's say maybe the fact that we need to form a triangle with that, we see the fact that we have another side, which is this side, right? Meaning it's either this triangle needs to be the one that we're proving similarity, or it could be this one. Do you see the fact that since these two are equals to each other, we can take this one also as being a reference? Because if we prove using the ratio, is that since these two are equal, are basically taken as the same thing. So from that, we see the fact that another side that we can take from the triangle, meaning this one, meaning the first triangle is going to be this one. Hope I'm making sense, right? Then our second triangle is going to be, needs to have this small base, this one, right? So it's going to be this triangle. Because both those triangle has this side, which is from this side, right? Because they are both equal to each other. It has this side in it, and it has the long side, and it also has this side. Meaning everything that we need from here is in those two triangles, the blue one and the blue one and the yellow one, right? So now we're going to prove similarity. And if we're looking at those two triangles, we see the fact that angle A2 is common. Remember that we need two angles, then the last angle is going to be sum of angles in the triangle. We see the fact that we know the fact that this angle here, we see the fact that we have this angle A2 as being common because it's both in the blue triangle and the yellow one. So we have one angle. Remember that we need two angles. And we see the fact that angle, B2, which is the orange one, is equals to this angle, which is angle C. So this is the second one, meaning the remaining angles, which is this one, right? And this angle from the yellow one is going to be the sum of angles in the triangle. So using that, this is how we're going to basically answer this question. So we need to basically name the triangle. Remember the fact that how you name the triangle needs to be in the way the angles are basically form together. Hope that makes sense, right? So we're going to say, if we're going to say in triangle E, right? So if we're going to start with E, maybe what you call this, EBC. So let's do that. So if we say in triangle, so in triangle E, let me say C, B, and triangle, from what we're going to prove, we see the fact that E matches up with what? So E, right, from the big triangle, from the small triangle matches up with E. So we're going to start with E. Then C, so C on the big triangle matches up with B on the small triangle. So it's going to be B. So we know the fact that it's going to be what? E, B, D. So D is the last one. So it's going to be D. So we know the fact that the first statement, right? We see the fact that angle A2 is common. So we see the fact that E2 is common. Then we see the fact that angle B2, is equals to what? Angle B2 is equals to angle C. And that's going to be what? That's going to be 10 chord theorem. Then the third one is going to be the third statement, which is going to be B2. So if B2, so the last one is D1 is equals to, so D1 is equals to EBD. So it's EBC, sorry, it's EBC. And that's going to be sum of angles in a triangle, sum of angles in triangle. Right, so therefore we can conclude, that triangle ECB, right, is similar to triangle EBD, right? And that's going to be what? That's going to be angle, angle, angle. Then we're not done. Remember the fact that we want this ratio. So let's copy that ratio. So we know the fact that ED, right, divided by what? ED divided by EA is equals to what? So if you look at it, right, if we say ED, so ED, right, ED from here, right, and divided by EA, so ED divided by EA. So we see the fact that EA is the same as what? EA is the same as EB, right? So let me just change it. First, let me say first we have proven that EA is equals to EB. And reason why is that I want to use this, right? It's equals to EB. So why I'm changing this is that here we do not have EA, right? So meaning our ED is going to knock along out, it's going to be EA, so it's going to be EB, right? Remember EB is EA, ED is the same as EB, right? Divided by EA. So now let's go back to this, right? So we see the fact that ED stays. So it's ED stays, but EA becomes EB. That's what I want, right? It's equals to. Now we're gonna go back here, right? We see the fact that ED, wait, let me just do it like this. We see the fact that ED is this one, right? Divided by EB. So EB is going to be this one, right? So now let's match it up. The blue one, meaning it's going to be equals to EB from the other side, right? Divided by what? It's going to be divided by the yellow one, which is going to be EC, right? So meaning it's going to be ED is the blue one, so it's going to be EB divided by EC. So now you have your ratio, but remember the fact that in the original question they want EA, right? So I'm going to just replace EB by EA because it's the same thing. So therefore, my final answer is going to be ED divided by EA is equals to what? Is equals to EA divided by EC. And that is writing in what? This is writing it in a geometric form. So therefore, you can say that ED, comma, EA, right, comma, and EC, right, form, which you can see, form a geometric sequence, which it does. Do you see that forms a geometric sequence? So that is how you would answer this question, Anne.